Okay. I think. Okay, and also apparently I need to mute Discord manually now. That's good to know. Okay, we've done that. Hello, everyone who is watching. I have no idea how many of you are watching, because I am on, as you might be able to see, I am on a bit of a different um, operating system at the moment. This is uh, Bazite, which is it's not really a Linux distro technically, but it sort of is. It's an atomic image that is produced, and it's cool. It's great. So anyway, yeah, I'm a Linux user now. Yay. Okay. Gonna mute my phone as well. That was actually me getting the notification that I'm streaming. That's very fun. And I think everything else here is fine to have up here. Let's close out of some stuff here. We'll close out of Steam, just cause. And otherwise, I think we're all good to go. Um, so yeah, welcome everyone. Let me see. Actually, let me double check that this like chat overlay is working. I'm not positive that it is. In fact, I don't see it. So yeah, I'm pretty sure it's not then. And I also can't see chat here because for some reason I don't know why. I'll try to fix that for next time because I would like to be able to see it. Um, I guess I'll just pull it up on this other window that I have here. YouTube.com. View my channel. Can I like go in? Sorry, 1 second. I'm like live troubleshooting here. So I feel like I should be able to go in and view it through YouTube Studio. Like live stream stats or something. Is there like, can I press this button? Like a little control panel thing? Ah, perfect. Okay, 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 okay. You can only hear you in your left ear. Is that just you? Probably not just you. Let's see if I can fix that. Oh, yeah, yeah, no, no, you're right. You can only hear me in my left ear, in your left ear. Let's fix that now. Um, if I go here, I can set this to be mono. Okay, you should be able to hear me in both ears now. Because I just switched it to mono, so it should be fine. Yeah, my voice is now on both sides. Okay, everyone, I'm glad we all agreed that you could only hear me on the left channel, but now you can hear me on both channels. Amazing. Okay, right? Everyone agrees in chat that you can hear me on both channels? That's true? Okay, well, we can hope so. Yay, it's fixed. Okay, cool. See, I kind of know how to use OBS. Isn't that great? Okay, I'm gonna pop out chat, and I can do cool little Linuxy things to pin this window, I think. So it stays on top of other windows, which will be very useful. Or maybe I can't. Do I know how to do anything anymore? Is a question. Well, I don't actually know. Okay, well, anyway. Yes, you can hear me out of both channels. Fantastic, everyone. Mic should be clearer than before for some reason. I don't really know why. How's volume? Is volume fine, folks? I hope volume is fine. Yeah, I'm gonna have to figure out setup at some point. I'm lazy though. So, welcome. Today we're going to be working on Suzumiya Haruhi no Heiretsu for the Wii. And so let's pull up some information about that. So here's my new browser window over here that will function as function as our searching browser thing. Volume good. How's life? Life is pretty good, Fonz. Thanks for asking. So what we're gonna do here is I'm gonna show you Suzumiya Haruhi no Heiretsu. Now, Heiretsu is the game that my group is translating. Okay, these are just Haruhi. That's not helpful. Okay, I guess we have to go to Google to get good image search. Actually, this is also just Haruhi. That's Gekido. Okay. The trash search options, man. Okay, anyway, here is the parallel of Haruhi Suzumiya on the Haruhi fandom wiki. I don't want to click that ever, but, you know, that's what we're going to click today. Yeah, so here is the lovely little cover of this game. Yes, Bazite fixed me, dude. Bazite fixed everything. It's so good. Anyway, yeah. So this is Suzumiya Haruhi no Heiretsu for the Wii. Now, I guess the other thing I can do is rather than just show you a picture, I can show you the game. The game itself, which is kind of a fun thing. And here's also, if you go and you search it, you can see also there is this video that comes up that has 1.1k views now. That must be the most viewed video on the Haruhi Translation Club channel, I think. It's gotta be. Let's see. Yeah, 1.1k views. That's more than our initial trailer release. 1.1k views on the parallel of Haruhi Suzumiya special version kiosk edition. Yes. So this is a 36-minute video that Will put together that shows some hacking that I did of this game. And as you can see, this came out 3 years ago. So I've been working on this game a little while. And so you can see here, like if you scroll through, we can just kind of scrub through, we can see like that there's all this interesting stuff we discovered about this special version. All of this is documented not just here, but also if you go to TCRF, the cutting room floor, you can see that we have a lot of documentation here. A bunch of it that's Will has written, a bunch of it I've written. I've done almost all the research into it. To figure out all this kind of stuff, which is pretty fun. So yeah, we need to update this more. I've been mostly focusing on updating the... Oh, Will! Hello, William. Hey, Will, you're free to join the stream, by the way. I will hop in. I can hop in the Junko stream hangout if you want to chat about Heiretsu. I know Heiretsu is your jam. So, yeah, TCRF is the GOAT. It's true. Let me turn down my volume a little bit. I think it's really loud. That Will jump scare, hell yeah. Will, hop in. You don't have to, Will, no pressure, but if you want to, William, you are allowed to hop in and chat about Heiretsu if you'd like to. Can't right now, but it'll hover around. Okay, fair enough. Other mods, you can hop in the channel if you want. Anyone who wants to talk, I don't care. Anyway, Suzumiya Haruhi no Heiretsu, yada yada yada. It's a good game. It's a cool game. We like it. Awesome. So yeah, let's try playing it a little bit. So this is Dolphin with the debugger UI up. Don't worry about it. It's fine. Here, we'll full screen this. So yeah, this is Suzumiya Haruhi no Heiretsu for the Nintendo Wii. Sega. Yes, they speak Spanish. I cannot do that. I can speak a little Japanese. Unfortunately, I can speak no Spanish. I'm very sorry. I can say hola, ¿cómo estás? That's the extent of my Spanish. I've never actually been to a Spanish-speaking country, which is kind of surprising given I live in America. So, this is, yes, Sega. So this is like, the interesting thing about the Sega thing is, as you saw there, they originally were going to go with a logo, a Sega logo, similar to, I forget which button pauses it, yes. Speak Azuri, I can't do that either. Game loud. Okay, I can turn down the game volume. Okay. How is... 1 second, let me go back to chat. Let's see how this is. How's that? Sound better? Volume down better? We'll find out in a second. Maybe it's... I might be blasting your ears right now, but I think it's probably fine based on my leveling. Yeah, I think it's good. So anyway, this is Suzumiya Haruhi no Heiretsu. Coming up here is a bug in Dolphin, actually. That works better. Excellent. So coming up right here, you'll see a bug, a very, very fun bug. That is only happens in Dolphin. It does not happen on the actual Wii. But you'll see there's going to be an overlapping event line here. And there it was. There it was. His lines, his monologue lines overlap. And so the reason they're overlapping there is because of differing frame rates, virtual frame rates and actual frame rates on the actual Wii and Dolphin. And so basically, an actual Wii, for whatever reason, has some sort of like processing hiccup there that the developers actually accounted for when they were doing the frame timing. And there's like a frame rate drop while they're loading certain scenes. And that results in, yeah, it is. Yeah. You're totally right. Yeah. Isn't that wild that they put it in Kobe Port Tower? Yeah. It's kind of cool. But anyway, yes. So that's kind of a little bit of a fun thing. Anyway, that gives you an idea of some of what Heiretsu is like. We'll skip here. Those were all event scenes. But one of the things we found out recently is that these right here, these script files, which have this style of it as opposed to the cutscene style you just saw before, those are events. These are scripts. So scripts are one of the things I understand the most about Heiretsu. However, despite understanding quite a lot about scripts, we've been finding some bugs in the script replacement, which means that I don't understand everything about scripts. So, what that means is that we're going to be spending today figuring out various script things. Also, hello, Cruiford. Hello, Cruiford. Glad to have you here. But we're going to be figuring out various script things today. That's like kind of the main focus of today. But the first thing I thought I'd do is kind of give everyone a little taste of some ROM hacking, maybe. And so to do that, we're actually going to go in here. I found a method earlier that I thought was interesting. And I'm going to have to go through a lot of these. Sorry, 1 second while I find it again. It was like a THP method. Yes, here it is. So, this method here is going to load. You can see it loads sega.thp. Now, THP is the Revolution and I think it's both Dolphin and Revolution. So it's both GameCube and Wii video format, one of the main Nintendo proprietary video formats. And I believe this is going to load. This loads this video in, obviously. Like, it has the file name there. Seems like it should load it. Like you can see down here. Yep, just sega.thp. So it really seems like that should be loading it. However, you'll notice that over here we have THP file, and then we have this other parameter that we don't know what it does right now. So I thought something that would be fun to do is to try changing that parameter and see if we can figure out what it does. Because currently it's this round 256 OX100 or hex 100. So, you know, I mean, like, maybe it would be interesting to try messing around with that. So what we're going to do is we're actually going to patch this instruction right here. Yes, welcome, Orapuro. So this is, we're jumping right into it. This is assembly hacking right now. So this subroutine right here that is loading in this parameter, passing in the name of the file and the parameter hex 100. This hex 100 here is loaded in right here. You can see it's loaded into register R4 on PowerPC, which is the assembly, the architecture that the Wii and GameCube use. On PowerPC, your first parameter for a function is typically R3, although it can vary because there's floating point registers, so that's like a whole other nonsense, but typically R3 is what it is. So R4 is where the second parameter here, this hex 100, is going to get loaded into. So what we're going to do is, you can see here, this is actually a very simple instruction. So this li is, the mnemonic part is here, and then the data part is actually right here, these 2 bytes. So you can see 0100 is hex 100. So what we're going to do is we're going to change this to hex 80, I think, is what I want to do. So we're gonna go into Dolphin. They have an assembler built in. We're gonna start. Oops. We're gonna start a new file here, and we're gonna do li. I think I can just do. I don't know if I have to do R4 or just 4. R4 probably in Dolphin. I think hex 100. And so then I should be able to just assemble this. Yeah, perfect. So here you can see it just assemble. Oh yeah, so that's perfect. So what we want to do is just hex 80. Obviously, we didn't even need to assemble it because we could have just copied the bytes in, but you know, why not? And so then what we're going to do is we're going to go in here and we're going to have our patches. So we're going to create a new patch and we're going to call this patch THP something. And we're going to do a 32-bit replacement here. And specifically, we're going to do it on this right here. 8. I'm actually going to copy this, and then I'm just going to type the other one because I can see it in the other window. So here's the address we're going to do it at, 800 920D8. And then we're just going to do, I actually can't see it, dang it, 38800080. So that's going to replace that instruction. And if we want to see that, we can actually even set a breakpoint here real quick. Is assembly as scary as people say? You can translate PS1 game. I have never translated PS1 game. I'm not as familiar with PS1 as I am with other platforms, most notably the DS and secondarily the Wii. You know, you can translate anything if you put your mind to it. It's just a matter of figuring stuff out. As far as assembly, is it scary? No, I don't think assembly is that scary. It's not, I wouldn't write code in it normally. But assembly is just machine code. It's just code of a different kind. It's very, very simple code, actually, in a lot of ways. It can be hard to try to figure out, like, what it's doing sometimes. But, like, once you get the hang of it, it's not too bad. So let's set a breakpoint here. We're going to set a breakpoint for that address that we set before. And the reason we're going to set this breakpoint is so that we can see, and we're going to bring this down now. We can see when this loads, and I can show you that we did replace the instruction. And it should hit right here. Yep, perfect. So you can see, yep, LI R4 128. 128 is hex 80. So theoretically now we should have loaded in this. And if I did it, you know, I mean, I have no idea what's going to happen, honestly, but I guess we'll see. I don't know if anything actually happened there. But let's try setting it to 0. One of my theories is that maybe it controls the volume. But I don't actually know that, like the video volume. That's one of my theories. So I'm going to try setting it to 0 and see what happens there. Because, like, if we can't hear it at all, that will be more apparent. So let's see. No. So it does not control the volume. I don't know what it does then. So we are definitely modifying it, but I have no idea what it's doing. That's interesting. So we can look at the code here. So again, like the other thing is, like, when you look at this assembly, like, yes, you have the assembly here and you should look at it, but usually what you're looking at most of the time is going to be this decompilation. And so this is Ghidra, by the way. Ghidra is an open source program. Yeah, maybe permission or speed. Yeah, I don't totally know. I mean, like, we can see here, if we load up in here, you can see we have THP file here. We have param2. So this is the function that's actually loading this thing. And you can see, where is param2 put in. So param2 only shows up in these two spots. And this only shows up right here. So it only cares about whether it's equal to 0 or not, it looks like. So that's actually pretty interesting, because I did set it to 0, but actually this is part of a larger if statement, but no, like, it's an and, it's a bunch of ands. So, I mean, unless it's always failing. Okay, that's interesting. So we're going to set a breakpoint and we're going to see if we can figure out what's going on here, because this is interesting to me. Yeah, and this has nothing to do with what we're supposed to be doing today. We're just messing around. We're just trying things out. Because why not? That's the fun of hacking. You can just kind of do stuff. So here we go. We're going to load in here, and we should hit this breakpoint here. Yep, perfect. So let's see. So we have... okay, so this is where we actually do have to read assembly. So what we know here is that it's going to be comparing a couple of memory addresses, right? So we have this one is equal to 0, this one is not equal to 0, and this one and hex 100 or hex 100 is not equal to 0. So, and let's see what this is set to, actually. Let's see what some of these other ones are set to real quick. This one is not set in this method, it looks like. This is set outside the method. And then this one is actually set down here, apparently, is one of the things that happens. So I guess we'll find out. Okay, so let's see what happens here. Let's go back to Dolphin real quick. Yeah, okay. So we have comparison R0. So R0 is 0. And so we're going to continue on here. And then the next thing is we're going to load from R0. We're going to load, or from R13, we're going to load something somewhere off the stack. We're going to load that into R0. That value is 0. We set it to 0. Remember, that was the one we set to 0. It's going to compare here, and we are going to branch equal down to here. And then we're in the branch equal that we go to here. You can see we just went here. And so we went down to this label here, which is this subroutine here. So we went outside the if statement, basically. The if statement, the actual thing that happens in the if statement is right in here. So we want to see if that's getting hit at all. So let's disable our patch real quick. Yeah, okay. So we're going to disable our patch real quick, and we're going to see if that's getting hit normally. So that will be kind of interesting. I don't know. I have no idea if anyone's going to find this as interesting as I do, but I genuinely love this kind of stuff. I just find it so much fun to just mess around and try to figure out what things are doing. Okay, so let's see. So we have here, okay, so now we have this comparison. R0 is 0. We see that. Okay, excellent. Next thing we're loading in is that 100, hex 100. So that is not 0, so we continue on. And then the next thing we load into R0 is this thing from R27, which is down here. We load in something that is 0. So now remember this one, it wants it to be hex 100 and that to be not equal to 0. So this is actually going to be equal to 0. So that's problematic. So what we're going to do is we're just going to change this to 100. And we're going to see what happens now. So basically, like, before it was always skipping over this no matter what. Oh, you're fascinated. Good. So basically, like, before it was always skipping over this no matter what. So we're going to find out what this actually does. Maybe it literally just sets one value to 1. So, like, again, it could be, like, completely non-apparent what actually happens here. But we're going to see if we can figure out what's happening here. So I'm actually what I'm going to do is I'm going to hit play on this. And actually this loops a couple of times. So I think what we have to do is actually have to modify this memory value. Oh, no, did I freeze it? Oh, phew. I stepped out. Okay, cool. Oh, no. I think we're fine now. It said it once, and so it should be okay. So I think I can just disable this breakpoint now and see if we can see what's happening. Oh, that was interesting. It faded out early for some reason. Okay, cook. Okay, that's very, very interesting. So wait, I think I actually know what it does now. I think I have a guess as to what it does at least. So, what we have to do is we have to make a second patch here. So what we're going to do is we're going to patch this memory address right here. I think that's the memory address we want to patch. So what we're gonna do is we're gonna go in here, we're gonna go into patches, we're gonna go into our THP something patch, we're gonna edit it, and we're gonna add a new patch, another 32-bit one, this address, and we're gonna set it to 100. Because remember, it has to be equal to, or it has to be equal to 100. It has to have a component of 100 in it. Yeah. So here's what I'm thinking is that I think that it's a it triggers an early fade, and that the value you specify is how fast it should fade. Like it's the duration, it's the number of frames to fade over. I guess I don't know. I like maybe it's like if fade with input. I'm not sure. We're gonna find out here now. So remember, this can't be 0. We found out. So let's set this back to 100 for now. And we're gonna check this, and we're gonna launch it, and we're gonna see what happens. Again, this is just like literally a silly little THP video, but we'll see if this does something. Okay, so that did not do anything, but I'm wondering if I have to do input to make it happen, or if I just put the wrong memory address, because we saw something happen last time. So let's see again, and if it's just like skips with input. Let's see if that's the case. Okay, so it's not skips with input, so I'm guessing that I'm probably putting in the wrong memory address. I'm guessing it's like a pointer to the memory address or something. So let's do a quick this is where it's loading from memory. So let's go do a quick thing, and let's actually find what actual memory address this is. So we're gonna plug in our breakpoint here. Background was black always. Yeah, I think so. I think it was. Okay. I also should adjust the. There's a way to make it so that it game scales correctly. I think it's in. There's a way to make this happen. I'm sorry. Aspect ratio force 4:3 maybe. Auto. I don't know. Oh, okay, maybe that worked. I have no idea. Anyway, okay, so we hit our breakpoint here. So we're going to be loading from R27, and the value in R27 right now is 802.1288C, and we are going to be loading 3CA away from it. So what we're going to be loading here is 802.12C5. Let's see if I can do math. 0, 1, 2, 3, 4, 5, 6. C6. Okay. So, or 5, 6 rather. So 802.12C56. So 802.12C56. And theoretically, we should be back where we were. Yes, perfect. Okay, cool. So this is the address that we actually want to set. And let's see what we were setting before. Oh, it was that. Okay, interesting. Okay, well, now that we have the breakpoint set, we also can see, I think I still have my patch applied, right? So we also can see what this memory is actually being set to. And it doesn't appear to be being set to 100. So maybe I did something wrong in my patch. Let's take a look at it again. Yeah, so that is the correct address. I did set it to 32-bit, and I did set it to 100. But you can see here that it is not quite. Oh, you know what? I wonder if I have to set it to a 16-bit address. It's loading in a half word, not a full word. So I bet I have to do it, and we're at a half point here anyway. So I probably have to do a 16-bit address. So that's probably what that is, I hope. And let's just copy out this. Oh, I can't copy the breakpoint? That's lame. Okay, whatever. We're just going to stop this for now, and we're going to launch it again. And yeah, it set that this time. So let's see if it does something. Oops. Okay, so it didn't do anything this time. Interesting. Okay. So we do have the 5-6 is being set now. So we definitely saw it fade out early, right? Like I'm not just crazy. I'm not just crazy here. It did well, let's set that let's just do this. We can okay, one step at a time, Jonko, one step at a time. Let's do a breakpoint again. And watch what's happening. Like watch what's happening in the disassembler. That is the right move. If you don't know what's happening, watch what's happening. So, okay, here we go. We're going in, and we will hit the breakpoint now. Perfect. Okay, so let's go through this. So we have this first one here, loads in. It is 0, so it continues. This second one loads in. It is not 0, so it continues. This third one now loads in as 0. It is 0 down here. What the hell? Why is it 0? What? Who made that 0? Oh, did we set it to be 0 earlier in the method or something? I thought I didn't reference. I thought I said it wasn't referenced. Maybe it's referenced elsewhere. So, okay, so let's take a look at this, and we're going to look for references of it. Find references to it. So we have a whole bunch of references in all sorts of places, including like these select commands, which is interesting. I'm wondering though, we should probably stick to someplace close to where we are. So we're at 800A. So this would be potentially, this is the method we're in, I think, right? Yes, this is the method we're in. So let's look at this method maybe and see what it's doing here. I want to see if I can find, so this is a load. Let's try to see if we can find a store. So here's a store right here. And it is storing something. We don't actually know what. But let's see if this one's doing something interesting. This one stores 0 in it. So I wonder if this is running right before and is messing with our patch somehow. That is possible. And one way to find that out would be to do a breakpoint as well. So this is storing a value there. We can also just disable that if that's what's happening, of course. But just real quick, for now, we're going to change this and make it 0, 1. Okay. And we're going to watch what happens now. Oops. Sega. Oh, okay, interesting. I don't know. I don't know what's happening. Okay, I swear to God, it did something earlier. Like it definitely faded out. It definitely faded out. So like this is okay. We're gonna figure something out here. We're cooking. Okay, so let's take a look here. This is where that is being set. 3CA, 3CA. This is where it's being set to 0. So let's see if that is happening in here. Let's set a breakpoint for it here. And then we'll also... Actually, you know what? We could just set a memory breakpoint on this point. That probably would be easier than doing anything else. Let's do that, because that will show us when it actually is getting modified. So let's do toggle breakpoint on it. And we can modify this breakpoint. It's read and write already, so perfect. And so then we'll just launch up, and immediately we hit this fill memory. That's fine. Fill memory happens at the very beginning when the ROM is first launched. It should, okay, it fills memory again. That's fine. It should get replaced by the 1 here. Yes. Okay, perfect. So this is happening at 800A for EDC. Is that where we are? No, it's not. So that is actually here. That's one of the other places we looked at. So this is this one, where it's pulling from some other place in memory. And so this is actually setting it to be 0 is what's happening here. It's storing R0 in that place. And by the time we get to the next read, it's been too fast for Dolphin to replace it with a 1 again. And so it ends up getting read. Also, isn't that loading my symbol map? Oh, no, it is. Okay, cool. Yeah, it's too quick for it to come back and repatch it, I guess, or it stores it over and over again or something. I don't know. Regardless, it's getting replaced. So that's all fine. Okay. So I think what we want to do is we want to patch out this store because that's the thing that's going to mess with us. So we're going to make this a no op. So this is here. And I actually happen to know the no op command off the top of my head. Just because I do. Don't ask why. But if I didn't, we could also just use that assembler, of course, and it would be fine. So here we go, and the no-op code, I believe, is... I think it's actually 6.8, but let's actually double-check that. Like I said, it's super easy to do that. You just go over here, you type nop, and you assemble. And it's 6.0. Dang. Well, see, that's why we check. Okay. Did I accidentally add another patch? No, we're good. Okay, cool. All right, let's see what happens. So we're gonna stop this now. We're gonna get rid of our breakpoint so that it actually stops. Okay. And now what we're gonna do is we're gonna do another memory breakpoint here. We're gonna reset it and we're gonna see if we can watch it get red. So store's fine, remember, that's all good. And then we get to the THP section. So here we're loading it. It is 1 now. It is 1 now. Here we're loading it again. It's still 1. Okay, perfect. So we've done that. We've won. Okay, so let's see if we can figure out what's happening. Ah! It does fade out. I knew it. I knew it. Okay, so it is a fade. It's a fade of some kind. So my guess is it's a... Well, it can't be frames per second, right? Because if it was FPS, like 256 is like multiple seconds, and it's very quick. So what would it be? Well, let's just try modifying it. Let's change the values. Let's see if we make it smaller, does it get shorter? Oh, I think Dolphin froze on me, so that's going to be a second. This just happens sometimes. If you, especially when you're in debug mode. Normally, Dolphin is like really cooperative, but when you're in debug mode, Dolphin gets mad at you really quickly, I've found. And that's okay, because most people aren't using it in debug mode. So it's, you know, it's fine. If, oh, is it happy again? It's happy again. Hopefully it doesn't close, because I just was telling it to close. Oh, it's mad at me again. Okay, never mind. Let's close it. And reopen it. Did it pop a thing somewhere I can't see? Oh, I have one unsaved tab. I can't see this window. I don't. Oh, okay. Man. Okay. There we go. I have one unsaved assembly tab. No, I don't care. Okay, Dolphin, let's come back. All right. So we're going to launch this again. I should have our patch applied still. And let's just double check that it does. Yep, excellent. Amazing. So what we're going to do here is we're going to go in and we're going to modify this value here at the top. So we're going to do what I did initially. We're going to make it 80. Okay. And let's see what happens. The Death Note music in the background. I think I have the soundtrack. Okay, so I feel like that was faster. Oh, wait. Did the AQ interactive logo also go faster? I feel like it might have. Is this affecting more than one thing? That'd be crazy if that's the case. I think actually probably the AQ interactive logo was reacting to my click, I feel like. Because those ones are... They do react to things. The video does not normally, is the thing. Okay, so let's try this. Let's set it to some really high value now. So for example, we'll set it to like 400, which remember that's hex, so it's something, I don't know. It's high. Okay, let's try this again. Oh no, interesting. So I don't know what. Oh, and that did not react to me clicking. That was just something that it did on its own. Okay, I'm curious now. Oh, but the reason for that probably is they probably reference the same value memory. Also, I can't click on this anymore. I don't think that's. I think that's probably something I did with my patch. Probably something I did. Oh, I bet they like check for input. I bet it's an input checker. That's interesting. I bet it checks input. Because that would make sense if it's checking input. Huh. Yeah, well, it only checks against one value, but that one value is used in a lot of different places. See, like this is used all over the place. So I think this value is like an input lock. In fact, I would not be surprised if some of these earlier commands. Let's actually check where some of these are used. I'm gonna have to exit out of some of stuff here so that I can see stuff. So I would not be surprised. Oop, geez, what did I do? Oh my god. I would not be surprised if some of these earlier ones are referenced in some of the commands. So like if we hit here, we hit Control Shift F on that. So no, that's not. Well, let's see. So where are the commands? So the commands here, like these are the obvious ones, right? So these CMNTs are comment, or is what they probably stand for, but they actually are selects. You get to make your choice in branching the story in some way, is what those commands are. And those are in the 805. So these are the only ones in the 805s. I mean, I guess I can look at this 806 and see if it's referenced somewhere. Interesting. No, not particularly. Anyway. Well, yeah. Anyway, so this is ROM hacking. This is what it looks like. And that's just something I saw and I was like, that's interesting. I wonder what this does. So I'm going to say, yeah, I don't know. I mean, like it's definitely like a fade of some kind, but I don't actually know what the value itself does. That's the real question, is what does the value itself do? I don't know the answer to that. That would be a really interesting thing to continue to try to investigate. But I think we're gonna move on now and work on some of the scripting stuff. Yeah, so here's this parameter. It is very interesting. See, so like, yeah, so basically this parameter gets stored here. And then from here, we only check if it's not 0 here. Actually, yeah, let's check what this parameter is doing. This parameter is only in a couple of places. Oh, no, it's in a bunch of places. Okay, it's just finding them slowly. Give Ghidra a second. Wow, that's a lot of places. Am I searching for the right thing? I don't no, I'm searching for int for some reason. Okay, references, this. Okay, so yeah, this is in very few places. Like, literally just this method is the only place that this particular value is used. So we store it here and we load it in here to check it. Is that where this load happens here, right? Yeah. Yeah, it does. That's so weird. I have no idea what this value does then. Interesting. Well, we know if we set it to 0, it would... Here, you know what? Okay, we're going to do a little bit more of the THP patch thing because this is fun. We know if we set it to 0, it shouldn't skip, right? So, like, it does something, but I don't know what the value does. Oh, yeah. If it only cares that it does only care whether it's 0 or not. At least in this case. But it's kind of strange that it only cares whether it's 0 or not, right? Yeah, so this did not fade this time. And neither did this. Yeah, I'm not sure what that indicates. But yeah, I absolutely break all input by doing this. The no op that I put in there breaks all input. So we're going to say let's disable that one. But pretty cool. Pretty cool. Yes, it does. That was something that I sort of, I don't know if I discovered it, but this is the debug logging. If we go into the logging tab, you can see actually it has a whole bunch of logs, all sorts of logs that it's doing. This also is all of the file logging and all this kind of stuff. So yeah, it like that's it opening specific files, doing specific things, loading that THP. I don't know what move buff use is. I mean, it's obviously some sort of buffer thing, but I don't really know what it means. Yeah, other kinds of stuff like that. It's interesting. There is actually one other thing that I wanted to check on before we get into the thick of things, though. And that is, I wanted to look into some command stuff. So, there is a method here called like script engine or something. No. Is it execution? Execute script command, maybe, is what I'm thinking of. I need to like be better about documenting some of this stuff because it's been a long time since I looked at this. So there is a place where there is a mapping between script commands and the functions that they actually, you know what the easiest way to do this is just to go to a script command function. So let's just do that. We'll go to command BGM. Why not? And so command BGM, we're going to find all references to it. And there's one reference out here. Yes, perfect. So this is the address that has this command BGM. And you can see we can actually, we're going to go in here and we're going to make sure that our data is appropriate. Is there like a shortcut for that, or did I just hit Y? It is, P is a shortcut for it. Excellent. Okay. Okay, I think that's probably the end of that. So I don't think I need... Oh, wait, no, is there more? Okay, I don't know. We'll see. So there's a bunch of these zeros that presumably were commands at one point, but aren't now. But there's also methods that look like commands that aren't referenced in this. So I'm wondering... Oh, the zero. Some of the zeros are not pointers. Those are padding. No, no, they're some of the... Oh, no, no, yes, they're padding. Yes, yes, yes. Probably. Because this is padding as well. This is going to a null op. Wait, but what is going on here? This is the extras data. Omake data is extras data. So most of these are padding. Whatever, it doesn't matter. We're just going to keep going up the list. Okay. And let's keep going. Sorry, I haven't formatted this already. We've migrated the whole database recently, so I've been working on making it nice and pretty looking. But obviously it's not quite there yet. So keep that in mind going forward. So yeah, I think this is, yeah. Oh, whoops. That's not what I wanted. Yeah, so most of these are in here somewhere. Oh my gosh, there's so many commands in this game, like truly so many. It's kind of insane. Like they did not need to go that hard on the scripting engine, but they really did. They didn't need to make a whole 3D visual novel, but they really did. Oh, no. Cancel. So what are these? Yes, good question. So these are pointers. So basically, the game has a scripting engine, right? And every single scripting command has an associated function with it, associated subroutine. And these are where those subroutines actually live. So basically, what the game does is, in order to determine which subroutine to run, is this a real thing? It is. These are still commands up here. In order to determine which subroutine to run, it has a method that like references this table down here to determine which of these subroutines it should actually run. And so these are all references to those to these are like the actual, like, this is a table of the functions that the commands actually run, and then there's a separate table in the files that has the commands in order, and then there's a function that maps between those two things, I guess is the easiest way to put it. And so that's what we're kind of just cooking real quick here as we go through these. Again, this is something I should have done. Is there a way I can I just, am I being stupid? Can I just do this? Like, if I just highlight all of this and I press P. Okay. Yeah, so I was being a little stupid. Okay, that's okay. Live and learn. Do I know anything about editing PS2 games? A little bit more than PS1 games, because there is a Haruhi PS2 game. But like, honestly, the techniques that you use for editing any game, they're all the same, more or less. You just gotta get into the files and figure it out. Hello, how's it going, Deathkill? Good to see ya. Good to see ya. Yeah, you just go into the files though, and you just kind of like mess around. You go into the assembly, you mess around. It's the same stuff for all of them. It's just a matter of being familiar with the platform internals and specifics. And I am not so much familiar with the platform internals and specifics of the PS2, but I'm gonna become more familiar. It's going great, my man. We're hacking Suzumiya Haruhi no Heiretsu today, which is always a fun thing to do. Is this no? So these are different. Oh no, these are commands, and they have. Oh my gosh, are these commands that I don't know about? Because that's crazy if so. Yeah, because these are all definitely commands as well, right? But some of them don't have labels, which would imply that it's a command I don't know about. No. Oops, I put too many pointers on that one. Set ear. Gotta love that command. Okay, so this is actually all of the data. Yeah, select all MP. Yeah, I should have done it. Sorry, I immediately forgot that I could do that. That's hilarious that I didn't immediately. I just immediately went back and do it. Oh, what am I doing to them? Oh, I'm in this is in Ghidra. I'm just making it so that they're viewable and searchable. So basically, like, I'm pressing a button on my keyboard to convert it from raw bytes into a pointer. And so Ghidra now recognizes this like raw data here as this pointer to this method is all that's happening. And so what we're going to do is we're going to look here. So there's this pointer here and another pointer right after it that actually are in execute script command here. And I should go back because I didn't click on the right thing. Here is the location that it's at. Yeah, so look at this pointer here. It actually pulls up the pointer and then goes and executes as long as this method is not. So yeah, it pulls up the method somehow. Let's see. So it might actually be easier for me to parse this in assembly than in this. So basically what happens is, it's actually not going to be easier for me to parse that in assembly. Never mind. Sometimes you say things and they're just not true. So okay. So param 2 here is actually a set of it's I believe this is the yeah, so this is the command definition. Okay, let's make that shorter. CMD def. Perfect. Yeah, each entry is 8 bytes long, you're correct. And that would be easier to do that, but oh well. You're absolutely right. But you know, oh well. So let's see. So yeah, so basically like if this is where it actually pulls the function out, right? And so if the function is a null function, if it's 0x0, then it just marks the command as completed and moves right along. And otherwise, it goes and executes it, passing the command definition to it as the argument. And then this right here, this hex 26. So we should make a struct out of this probably. The hex 26 times 2. Oh, so the times 2 is, of course, the making it so that it's 8 bytes long. And so then this must be the offset that it has. The command definitions must all have offsets. So yeah, let's take a look in the debugger real quick. Actually, this will be a fun and instructive little thing to do, I think. So let's see. So let's just do it right here, I think makes sense. This is where it actually loads in the command definition, and we'll actually be able to see what the command definition structure looks like in Dolphin, which I think will be useful, and making a structure in Ghidra. So let's make sure I don't have my patches on. I don't. We're good. Okay. We don't need to set a breakpoint right away, but I'm still going to do it just because. And let's launch the game. So we're going to fast forward real quick. Okay, hey, we hit this right away. Interesting. I didn't think we would hit execute. Oh, because we immediately execute the EBT command. That's right. EBT play is the first command in this script. So we have we're loading into R4 the value that's stored in R31. So R31 is 917C2E0, and we're going 4C from there. So let's go down and switch this to dual view is what I want. Do they have Shift.js view yet? No, they don't. Okay, whatever. It's fine. Okay, so this is our script command here, our script struct, if you will. And so this, if we go 4C, that should tell us which command this is. So this is command 17, and that's the offset that's related to the offset that it has into this table here. So we also have documented, I have documented on our wiki, Heiretsu translation. I typed it wrong earlier and it saved it. That's stupid. On our Heiretsu translation wiki, I have documented all sorts of stuff about the scripting language. So theoretically, we should see if we go to command 17, that is wipe. Interesting. I don't know. I expected something different. I expected EVT, like event start. I'd expected, which is, are these? Yeah, these are hex. Okay, cool. That's okay. Oh, you know what? Actually, I don't expect that. I expect something entirely different. And you know what? Here's the other thing is we can, real quick, we're going to pull these up in, I think I have to run a program real quick. Okay. So we're going to run a program real quick. So we're going to run the Heiretsu CLI, and we're going to extract, actually, have I extracted the game even yet? I installed WIT earlier, but did I actually extract the game? I did not. Incredible. Okay. So let's do that. So we're gonna go to ROM hacking, we hacking Heiretsu, and we're gonna do wit extract, Suzumiya Haruhi extract. Okay, so that will extract the ISO. Yeah, Ghidorah will generate the struct. It just is. I don't like doing that very much because often it's pretty inaccurate. Like it only has data based on what it's referencing in the current scope that it has understanding of. And so as a result, it can be a little bit misleading sometimes. So I don't often do that. Okay, so now what we're gonna do here. Sorry, I'm like yawning. I didn't get as much sleep last night as I wanted to. Now what we're going to do here is we are going to export scripts. So we are going to do export scripts, presumably. Yes. Scripts. And we actually want to give it this as our working directory. So export scripts scr.bin scripts. And we'll include the indices because that's going to be very helpful. So we'll do that. And then we'll just run this real quick. Should work. Yep. Yeah, sure. Oh, it didn't work. Why didn't it work? Oh, it couldn't find a file. You know, that's valid. I thought I gave you the right working directory, though. Why couldn't you find the file? Oh, because I didn't give it the right working directory. That would be okay. Yeah, fair enough. Thought I did that. So okay, now I did that. All right. Okay, I think it's done. Yep, here's scripts. So let's open up these scripts with VS Code. So this first script that's loading, if I recall correctly, is this one, I believe. So the very first thing that happens is log true. So log, I think, is command 1, actually. Also, I probably already have this structure described in code. I don't know what I'm even doing. No, cback is command 1. Okay, so what command is log? Let's see. Log is F. So let's look in here real quick and see if we see an F. And I do see some presumably Japanese. That looks like Shift.js to me. I could be wrong, though. Oh, no, that's memory addresses. I take it back. That's 2 memory addresses. Okay. So R31. Yes. And we're going 4C from R31. So we have 17. 0001. Yeah, but no OF. Interesting. I wonder why. Oh, no. Actually, log is not the first command executed. Scene set is the first command executed because log is a zeroed out command. So it does not get executed, but C also doesn't really help us. I didn't see any C's either, really. So that's kind of annoying. Let's look at the code that I've already written, though, at this point, because, I don't know, makes my life easier. I already figured out a bunch of this, so why not use it, right? So a script command. Oh god, I need to document this. Oh well. A script command appears to have a couple of pieces to it. So it has an index at offset 2, apparently. That's interesting already. And then it has the number of oh no, sorry. Yes, that is right. Wait, what? Is that, wait, what? Is that okay? Those are both reading the same thing. Is that a bug? Is this a bug in my code that's been here since the beginning? But that can't be. How is that possible? What the hell? What the hell? I mean, it's getting it from the data. Okay, wait. We're gonna run that again, and we're gonna see what happens when we plug this in, because that's really weird. Okay, so we have our data. That's a lot of data. That doesn't feel right. Also, this is horrid. This is so bad. Okay, wait. So read short does what? It does binary primitives. Yeah, okay, that's fair. Okay, so index ends up being 1 because oh, I see why it's that. I see why it's so big. Okay, I see why it's so big. The reason it's so big is not because it's because we're not truncating the data. We just are using what we have in order. Okay, cool. Sure, fine. Okay. So 1 is our index. And then we read ushort num params also 1. Is that a coincidence though? Huh. This is very I don't know what's happening and I don't like it. I don't like that these are both 2. You know what? Let's get blame. Wait, I'm already in the repo. Forget blaming. Strings, scripts, script command, blame. So I did do some refactoring kind of recently, but most of this was done like 3 years ago, as you can see, like when I started working on this. Okay, so here's this improve perf through spans. So this is 8 months ago that I did this. Let's check what the script command. Yeah, sure, script command. Oh my god. Oh my god. Yeah, that's a bug. I introduced a bug. But how is it working then? What the hell? Yeah, so the issue was that I had this take 2 that's like take 2 bytes and I made it do the offset of 2, but it should be offset 0. How does this work? How is this working at all? Is this the source of all the bugs? Is that I just typed the wrong number? What the hell? Okay, if I do that, does that wait, no, I have to do something different. Okay, wait, 1 second. So, okay. Let's turn it back real quick, and then we're gonna run this, and we're gonna have all the scripts. We should be able to diff these scripts one by one. So let's do. Okay, yeah, we'll leave those there, and then we'll do in writer. We'll make this one scripts fix. It shouldn't work, but it does. Yeah, it's really true that is the common programmer issue. This is not good, Millie. This is not good. Okay. Oh, did it not? Oh, okay, cool. Well, it just didn't work at all because I had used the command wrong. Okay, cool. Scripts fix. There we go. Okay. So now we have, okay, so now we have a second one to compare against. So let's open up in our, here, let's close out of this VS Code actually and use the other VS Code. Let's open up another workspace, add folder to workspace. And we're going to add scripts fix to this workspace. Okay. So now what we're going to do is we can diff some of these files. So let's diff this. Actually, hey, Millie, if you don't mind, can you grab the number or ID of one of the scripts from Weblate that was bugged, and it found bugs in? If you don't mind, I would really appreciate that. That would actually be a massive help right now. So we're gonna do diffing here. I think I can just do. Thank you. That would help a lot. Compare with active file. Okay. So these are identical, I think, right? These look identical to me. Don't see any differences. The blue does not mean different. So, okay. So those are identical, but my question is, I'm wondering if like some of these that we're seeing bugs in are a result of that. Like that's definitely a bug. So like I mean, like if it actually works, that's kind of horrifying as well. Like if it never breaks anything. But it is suspicious for sure. Um, good to review your code sometimes, I guess. Okay, that's interesting, huh? Yeah, that's wild. Okay, cool. Um, well, that is very fascinating, actually. I don't know how to feel about that. Okay, anyway, so let's keep going through here. So we have the index, we have the number of parameters. There is a name length, I guess, and then we can get the string. Of the name of the command. Is that what's happening here? Oh, is this from the commands file? The commands file? This might be different than the script files. Still though, it's weird that it would. Huh. I don't know. Okay. So we got our parameter types. We got all sorts of stuff here. Okay, so that's script command. We got script command block, which has various parsing things in it. Script command invocation, which actually is where the script commands themselves get invoked. So script command invocation has this parse invocation method. Oh, this is for parsing the string invocation though. We want to we want to construct it from binary. So we got a character entity, a command code, the count of the parameters, a 0, and then each of the parameters. Interesting. 193.03. So that's SCR 202. That's right. I remember it being 202. Okay. So SCR, it's SCR, it's 193. Okay. So 202 is the where it will be sorted as. Yes, F06B and 202 up here as well. Hopefully these are identical, and that's not the issue. Down here, actually. Okay, yeah, these are identical. Whew. Okay, so that was a bug, but it wasn't the bug, thankfully. Because that would be pretty stupid if that was the bug. So let's remove this folder now. I feel confident that we've solved that for the time being. Thank you, by the way, Emily. I really appreciate it. We're going to be looking at that script later today, I think. Okay. So that's one thing to look at. And then, let's just look here real quick. So I got to remember how these things work is the problem. So there's a compile and decompile method. Let's look at decompile real quick. Or maybe just parse script. What is parse script? It's different, it looks like. Yeah, so here's decompile. Okay, so there's a command.name here. Okay, so this is very interesting. I'm a little confused. So we have a parse invocation, but where do we construct these from data? I guess we don't? Question mark? Then we have resolve addresses method. That all makes sense. Parse parameters method, sure. Yeah, calculating all the different structures and stuff. I am uncertain. The big thing I want to know is, well, I guess we can look at the command and just see, like, what the actual command codes are or whatever, because that would be helpful. I mean, let's see. So, okay, so the command codes are the index of the command in all commands. So that's a separate file thing, right? If I recall correctly, yeah. Yeah, so let's look at okay. So there is a file in here that determines which commands are actually available and has a whole big list of all of them. And I believe it's in dat.bin. Could be wrong. Let's see. Okay, let's cook. Sorry, I'm like fading a little bit. I'm probably gonna have to take a nap at some point, but I really want to try to get through this. I don't know. Okay, so mm, okay, available commands. Got it. Okay, okay, okay. I think I kind of get it. So, yeah, so basically the script is composed of blocks. Um and I guess but then why do my numbers not match up with whatever is in this file? Like that's weird, right? I don't know. Here, let's like I don't know. I'm going to try extracting dat.bin and taking a look at it. Unless there's like a command for getting commands. I don't think there is. There is not. Okay. So let's do let's do a special command. We're gonna do extract bin archive. Extract bin archive. And it will be I dat bin o dat or o dot slash dat and then decimal. Okay. Okay. We're cooking. So we have our dat here. Let's open up imhex. And then I believe these ones we want the odd files, if I'm correct. No, we want the even files. And the reason I know that, by the way, is this file is little endian. You can tell that because the little end comes first. And we want the big endian files because those are the ones that are actually real. This game has multiple for some reason. So here, let's close out of this one. And then we'll drag in 2. Okay, there we go. So that's not, it's not 2. Actually, what am I doing? I can just look this up again in the code. It would be in. No. Have to do it in decompile, right? Or I'd have to get the script command blocks. Oh wait, no, available commands is what I have to get. Oh, can you only get it through opening the MCB archive? I guess that's fine. So we'll open. Oh wait, but I can't do that because that's in it's in a different thing. It's in the Windows version only. Well, I mean, I already have the methods, so it shouldn't be too hard. Oh hey, I'm glad you like it. Oh, and thank you so much, Pigo. I'm so glad, or Marissa rather. I'm so glad that you are enjoying the stream. Okay. Let's see. There's got to be a way to go about doing this that will make this work nicely. So what I'm gonna do here is, um, okay, where does it populate available commands from? Oh, populate command blocks? Is that what we're doing here? Oh wait, how does it get script commands? That's the real question. How does it get script commands? Script commands is passed into it. Um, it is the second file in scr.bin. It seems. So it's this one. Or was it the one before that, actually? As groups, sound effect. This is all flags, I feel like. It's not. Oh, this is dat.bin. I just said the second file in scr.bin. That's why. Okay, so let's extract scr. And I'm really glad you found my videos encouraging. That makes me feel quite nice. I hope you continue to enjoy the content that I put out in the future. Okay. So now we can open this in Impacts. Why am I using an IDE? Because this is C# in the background there. And I've written a program in C# to real programmers use Nano. Yeah, I'm about as real a programmer as you get, and I don't use Nano. Anyway, so this is the file that we were looking at before. So I think this is our index, our number of commands, the name of the command. Real programmers use butterflies. So true. And then this last thing is something. So we've got, okay. Okay, so wait, let's go back to our struct that we have here. Script command. Okay, so we have index at 02. So this is 0, 0. And then we have num params 0, 1. It's 1 param. Then we have name length is 5. It's the length of 5. And then we have the string. It's 5 right there. There you go. And then we have a number of params. We have params. Okay, so then we have this one describes the first param, the only param that it has, and yeah, and that adds that in. Okay, got it. And this is the definition of what type of parameter it is, I guess, right? And if I go back to, my God, this is really something. If I go back to take a look at, 1 second. Real programmers don't program. Real programmers gatekeep. Oh my God. Y'all are wild then. Okay. So 0, 1 is a string. Okay. So we're on the right track here. 0, 1's a string. Okay. And then the definition length is considered that. Okay. So this makes sense to me. That's the definitions of the scripting engine stuff. And so then the order that the commands appear in this file is the order in which that's their index into that's the order they appear in the actual game as well, apparently. So therefore, if I just go into writer here, actually, I can just like get this. Think, right? Wait, why did that? Oh man, that should have hit. I feel like, but oh well. Yeah, export scripts command. It should, right? Oh, I'm not exporting scripts anymore. Duh. That's why. Export scripts. Oh, scripts. X. Okay, now I should hit it. So we don't need this. We don't need that. I should hit it. Yeah, man, I'm fake programmer by helping people. So true. Okay. So here's our list of commands. And this is in fact the order that they appear in. I think it is, right? Camquake comes last. No, it doesn't. Am I just like completely wrong about everything? So we have back, C back, end, loop end, free, exit. I mean, that all looks right, right? 9 is that. So let's just pick a random. So scene set is 12. That's 12 here, yes. MW is 24. 24 is, of course, 1/8. Well, actually, I can just look at the decimal, can't I? No, sorry. 24 is 36. So 36 is MW. Yep, okay. We'll pick another random one. Map change. That's 3E. That's 48 plus 14 is 62. Map change. Excellent. And then we've got tutorial. That's 68. So that's 4/4. Sorry, 68. That's not 4/4. That is 16 times 5 is 80 plus 96 plus 8 is 104. Is that right? Oh, there aren't that many commands. OX76 in decimal. 118. And yet there are 99 commands. Well, some of them are going... What happened? What happened here? Oh, is this just the first page? Am I stupid? Yes, I am. Okay, there's 119. We're good. We're good. We're golden, guys. Don't worry about it. Don't worry about it. All's good. Talk is 60. Yep. Okay, all of it's good. Awesome. Okay. I'm successfully... Yeah, this is pretty good, I think. This is pretty good. And like 100 is like 64, right? That's random. Perfect. Okay. So I think this is good. I think this is generating correctly. So I guess the question is, if we go back to Ghidra, can we map this? So we go here, for example. And the first one we should see should be... Okay, so the first one is actually end. And then we have back. And then we have free, which is not C back. So there is some sort of mapping here that's happening to get, because free is 4, but it's this one right here. So there's some sort of weird mapping happening here. And end is in there, I'm pretty sure. There is an end command. Yeah, it's 2. So these are out of order. So there is some sort of mapping happening somewhere. So let's take a look at this again. Okay. So apparently in the command definitions, at hex 26, which we have the command definition open, right? Unless it's not the command definition. Is this something else? Oh, thank you for hugging me. I appreciate it. Okay. So, I mean, so 2-6, like, so let's just say hypothetically that this were in here. 2-6 would be out to here. So it's like definitely not, because that's in the middle of the end command, right? Oh, thank you, Millie. That's so sweet. Yeah. So, okay, so let's take a look at this command definition struct again that we have up in Dolphin. 4C is this. So 17 is what it's going to load here. So 17 is probably correct in terms of getting to this command in this table, right? Like that's the case. But where does it get this 17 from is my question right now. Well, actually, here's a question also. What is log or scene set or whatever? Log is... what command is log? Log is OF. Log is 15. We'd established that. And scene set is OC. So, okay. Not helpful. Okay. So Google... Okay. Oh, you know what? No. So is this command def? Where is it? So this command def comes from somewhere, right? Specifically the command def. Wow, it comes from all over. Has Jonko lost his mind yet? Well, you know, he's doing okay. He's doing okay, Will. Will, are you a moderator on my channel? Did I make you a moderator on my channel? Is that why you have a little tool wrench thing next to you? That's pretty cool. Is that the case? Oh yeah, you are a moderator. Will, you need to come moderate my channel more. Come to my streams and mod for me, bro. Okay. So no, yeah, you're definitely a mod. I clicked, bro. Yeah, you're good. Okay. So basically, like it looks like the stuff starts at hex 2-4 maybe. I'm like reverse engineering all of this all over again, which is fun, real time. Okay. Okay, no worries. You're gonna BTB, bro. Hell yeah. Love that for you. Oh, wait. So it's storing. How does script store? It stores param2 in param1. Dest source. So it stores the values in hex 26. So hex 26 is like determined. It's not it's constructed. So when we get down here, although actually I don't know if that's correct still now that I say that, but I think it's correct. Because here's this x26 again. So CMD def plus hex 12. It's -1. Let's just hit play, see what happens. Nine 914-071F. Do we see an F in here? Is the question. I mean, like, we can also look for a set. This is interesting. I'm not sure what's going on. So, no, sorry. 2E, 2E. So those are all the set commands, right? It's the same thing loading over and over again. And then it should load a different one next time for S menu lock. No, it still loads 2E. Does it always load 2E? No, 4.6. Okay, so I just counted wrong. There's 4 set commands. That's right. So S menu lock is 4.6. And then the next one is EV start. So that should be a different one. Yes, 5F. And then the EV should start. We go to EV mode. Yep, that's a different one. And then wait. And wait repeats. It's a repeating command while the EV event plays. Okay. So this has got to be stored somewhere. Somewhere it has to be stored. So the question is where? So we have, again, we have from R31, we have 917C2E0, and we're going out 4C from there. And so it is is 2.6. That's what it's loading. And so that must be the offset. Let's see what 12 is. What hex 12 is. It's fade. But what's wait? Wait is 1B. Okay, this is stupid. But what's 1B times 2? It's not that. But, you know. Yeah, it's 36. Okay. Okay. Let's keep thinking. Let's keep thinking. Okay, so we got our weight here. Yeah, I'm playing the game now. Okay. Interesting. Okay. So there's just gotta. Where is it stored? That's my question. Is where is this stored? Um, like how does this CMD-def get constructed? Because it gets passed in. Oh, it gets passed in. CMD-def gets passed in. So that is a hint. So let's see what references this. Execute script command. So this is in some sort of execution engine, probably. Yeah, do while ivar is not equal to 3, so, or not equal to 0, rather. So result, execution, result. And it constructs the CMD-def in here. So let's see how it constructs it. It does this beforehand. It also executes some stuff, apparently. Well, no, that's just a set. We need to separate out this variable. Ivar 3. And then we will separate this out. Split out this new variable. And it will be called execution result. There we go. Okay. So CMD-def is equal to this. And this is coming from some sort of like static file that gets loaded in. So let's see if we can find this elsewhere. A lot of places. Here's the first place we can find it. Let's look for a store, though. That's where this is going to be populated, wherever this is. So let's look in here, and let's look for a store. So these are all loads. You can see that's the LWZ. Here's the store word. This is a write to it. Let's see if there's any others. I'm betting there's only one. Oh, no. There's actually two. Interesting. Okay, cool. So let's look at the first one first. Everything else is a load. Okay, let's look at this one. So, is this just clearing the memory? No, it's actually storing something. We'll call this global CMD-def for now. Okay, so this is finding the end of the file. Interesting. Okay. So we got global CMD-def 0 hex 1694. Okay. So let's see. What can we do about this then? So this is just finding something here. So what calls this? This loads main story map, load extra modes are the two main callers of this. The only two callers, actually. So let's see. Let's just set a breakpoint here and see what happens when this gets loaded in. Because now I'm curious. Okay, hit our breakpoint. So let's see. So the thing that gets passed into this, it says void, and I guess that's true technically. So So 1694, there it is. And 4, there it is. Okay. And then we go into here, find end of file. I don't actually know what find end of files does. It doesn't seem to actually. I don't know. I guess this is. Oh, it's checking the offset of the previously loaded file, I guess. Which I don't know what that is. This is. I guess it's this. So if I go here, oops, just grab the entire UI. Okay, so if I go here, I can see that we have a pointer 914002EO, 914002EO. Okay. And we're going to find the end of the file here. So we're going to get a pointer back, and it's 91401974. Okay. So now we have a pointer here to where these CMD defs start, apparently. So we have a -1 here. Because this is now global CMD def, right? We're setting this to global CMD def on our next instruction here. And it cleared. Oh, did it just clear the whole? Oh, did it clear everything up to? This is where it's gonna go. I see. So it loads it next, I guess. Is that what happens? So, yeah, because that just clears the mem. That just clears memory. Yeah, global CMD def clear memory, and it clears the whole size of whatever it's clearing. Okay, cool. Well, that's fine. In that case, interesting. So, okay. So let's keep looking at this stores then. So that was that first store, and then the second store is right here. And this is maybe more interesting. This stores, I guess otherwise, like, oh, this just clears out the CMD def after it's done, I guess. But does this also load the CMD def? No, this is clearing the memory of it. This is actually executing some. Oh, is this like our scripting engine? Is this just the scripting engine method? No, it's not. It's something else, because this is actually executing something on it, which is interesting. I don't know what that is. Hi, welcome back. Yeah, I'm working on script engine stuff right now, Will, because there's some bugs in it, but also I'm curious about some things, so I'm just kind of like digging around randomly at this point. But I'm hoping that I'll figure out what some of the bugs are in that process. And then also I'll be continuing to do this throughout the week. So I got plenty of time to figure stuff out. But I wanted to hop back in, and it's always good to just kind of follow your curiosity when you get back in at first. So that's what I'm doing. That's what I'm doing. Okay. So yeah. Load main story map. Okay. So here's load main story map. Also, Will, I converted the entire old database into this Ghidra database that is stored on a server. Everyone can have access to it in our group or whatever. It's awesome. It's taken me so long because I had to do a bunch of manual work to convert it. Really sucked, but I did it. I did it. So where we just came from was this. So we should name this method here. Oh, not that one. This one. Oh no, yes, the one before that one. Yes, we should name this one SCR clear CMD def or allocate CMD def maybe. Probably calc. Yes, it is very nice. Okay, so calc CMD def. And by the way, this just returns an int. Just call it an int, probably at least. So let's again, we're gonna look at references and load the main story map is where we're gonna look. And so it's right after here. So this is the next thing that gets called. And we have a lot of stuff in here. So this is actually where we define global CMD def, it looks like. SCR define CMD def. Because we're actually defining a bunch of stuff in here. And there's a do while. That's what we'd expect. We'd expect some loops in here. Actually, also some like allocation of stuff. Interesting. This is a whole like huge ass method. Lots of other things it's calling. Lot ATB no error. And then it gives it a number. But we don't pass a number here. It doesn't show one. Interesting. Here, I'm going to refresh this and see if it figures out that there's a number. Nope. Okay. Yeah, let's see if we can figure this out. Okay, well, let's just again. This is sometimes it's like you can stare at this all day and like it won't make any sense unless you actually go in and like watch it work. It's magic. So let's go in. We're gonna set another breakpoint here, and we're just gonna step forward. Perfect. John coding. That's so true. That is what I'm doing. Okay. John coding. Yeah. Okay. So, okay. Let's start cooking here. So our memory address that we're looking at here, it actually takes place really high up too. Like 3DF is 991 apparently. 31 is 993. I don't know about this, but whatever, we'll see. This is where it starts. Like, we should probably look down here where it has lower values. Like, this is defining some other stuff up here, and this is actually like defining actual command stuff. So let's look here and see if we can figure out what's going on. Oh, did I just copy the same thing? I did. Made two of the same. Oh, no, I didn't. We're good. It's a different breakpoint. Okay. Okay. In fact, let's delete this other breakpoint. Okay. So we hit play. Cool. So, all right. So our thing that we're modifying, our global CMD def, that is done via, it looks like it's stored in R13. So R13 is right here. That is 802 BCC00. Okay. And specifically, it is minus 73E0 from that, apparently. So, okay, actually, it's not even that. It is this thing, isn't it? It's 914002E0. Okay. 914002E0. Okay, let's go. So now, here's what we're working with. We got R0 there. So we have R4 starts at 0. This is our beginning of our loop. We move 24 into R5. That's like the number of iterations we're going to do, I guess, or number of variables or something. And then we're going to add R0 and R30 together. So R0, R30, R30 is 0. So R30 is going to increment to get us through the different parts of what we're implementing or what we're incrementing through here. So there we go. And then we're gonna store some stuff. That's all good. Yeah, the casual negative pointer offset. Yeah, PowerPC loves those, unfortunately. And also, PowerPC doesn't have a way of loading in an 8-bit, or sorry, not an 8-bit, a 32-bit integer. So you load. There's an instruction called LIS, which is load immediate shifted, and you basically load a 16-bit integer in shifted, and then you OR it with another 16-bit integer to construct your full 32-bit address. Despite it being a 32-bit operating system, it has to do that. It's very interesting. I don't know that that's the most efficient way to design an architecture, but that's what it does. Oh, whoops. Okay. Okay, here we go. So R31, 0 in 44 R3. So 44 R3 is 0 here. Okay. And then now we're at the next one already. So these incremented by 84 each time, it looks like. And 84 is what in hex? 84 is 5-4 in hex, so that makes sense. Yeah, I've not worked with MIPS, but like it's probably pretty similar. The big thing is PowerPC has something in common with ARM though, which is that it is a fixed width instructions. So all the instructions are 4 bytes long, which is nice. But yeah, it is sometimes these instruction sets do weird things. Okay. Okay, we're adding 18 there. We added 24. We're gonna compare R28 to 4. We're gonna add 4 there apparently. Branch back up. Okay. This doesn't seem to be doing much useful for us, for our purposes. Because it's just setting stuff to 0, basically, yeah. And then clearing some memory. So yeah, no, that's not useful. We want stuff down here more. Which is funny because it's outside of a loop, but maybe something else is happening here. Let's also see, we know that like from before there's these 2 values that mattered, like 2, 6 or whatever. Oh, but these are getting casted. Oh, do I not have... Oh, is this type? Let's make this a type of short. What's this type now? Yeah, okay, short. Yeah. Okay. That might make this a little easier to read, is all I'm thinking, if we do that. At least occasionally easier to read. I don't know. I mean, most of this is kind of inscrutable. But that's okay. Um, This GX init is like wild to me. Like, what's going on here? Oh, it's just some random method that got flagged as GX init, looks like. Okay. Interesting, interesting. Hmm. What is Pyvar 4? Pyvar 4 is something with CMD def. And it has the right kind of numbers that we're looking for. And this has that error that we saw before. Interesting. So yeah, okay, like there's got to just be some static file somewhere that I'm completely forgetting about that defines all this stuff. Let's look at one real quick. I don't know. What does the first one do for us? Oh, I just crashed in hex. Nice. Yeah, sure. Oh, hey, look at that. Just restored. Not letting me open it though, so let's try again. Okay, there we go. Now it opens. So yeah, this is just the, I remember this. This is just the list of all the files in scr.bin. And so the first one is scr list, you can see, and then here's scr command that contains all the commands. And then you get into the actual scripts. So if it was gonna be anywhere, it would be an scr command, but it's not, as best I can tell. Okay, wow. That's twice in a row. Embarrassing me in front of people. Yeah. I don't know. So like these are commands or parameters rather. Those are parameters. Um or this is a parameter at least, and then this is I think the next command. Um Unless that index is, I mean, is that index the value that we care about? No, this is just it in order, in normal order. Unless I'm wrong. Yeah, no, that definitely is just it in normal order. Because yeah, this is all the data in that file, basically, is what I'm trying to get at. I mean, we don't have, well, no, we have the parameters here, too. Like, if we look at this one, we have parameters here. I just am trying to figure out how it maps. Okay, what is param1 here? Param1 is something with global CMD def. That is defined here. Let's look at this. Where else is this used? What's this? Where is this used? This is just in load main stuff. Mm. Hmm. I mean, I guess we can look at what it's doing. It's not gonna be super helpful, but we can try. Um, Set a breakpoint real quick. And here we go. Okay. Okay, so we're looking at whatever's in R0, 907, F244. That's kind of interesting. Oh, but it's 9075 FE24, doesn't it? Okay, didn't do anything though. Interesting. Hmm. I don't know. Okay. We can think about this some other ways. Um, so we have these commands for sure. We know where the commands are. There's gotta be a way. The way I mapped them originally, I think, was not through anything particularly clever. I literally just like typed different commands in, or like, set up different commands and then watched which functions they went to. So there's nothing particularly clever there. But maybe we can do the same kind of thing. If we go and we find our commands again. What does this pointer go to? Hmm. Okay. That looks very similar to the code execution thing. Where's this referenced? Some random place that I haven't seen yet? No. Okay, and where is this referenced? Where are these strings? Oh, those are subs. Okay. In load main story map and load extra mode. Okay. Okay. So I feel like maybe what I should do is I should look at the actual execution engine and see again if there's something I can figure out there. Um, so let's look at that. Let's look here. Let's go to our execute script command method. And it's going to pull this here. Here's command def. It's going to load something from command def here. Okay, let's set a breakpoint right here and try this. Here we go. Okay. So we're going to execute this next script command, right? So here we have, we're loading a 16-bit value from R31, which is this 917C2E0. And we're loading that into R3, register 3. That value is 1. So there's going to be no change in this register. And then from that, we double the value and store it. No, we do something else. Okay, wait, sorry, 1 second. What do we do to this value? Okay, so we store it. First we check to see if it's got a hex 80 component to it. And then we check to see if the command is valid, I guess. So we don't branch here. And then the command lives at this point, at hex 4C away or hex 26. CMD def hex 26. So we load that in. That's 1717. Because we can see if we go 26, we get to... Oh. Wait, what? From R31. 917 C2E0. Yeah. And I go to... Oh, sorry. I have to actually go 4C. I have to go 4C because that's the total distance, not 26, which is the index distance. So that loads 17 into it. And just to remind ourselves, 17 is wipe, which is not the command that we're looking for here, but that's okay. But I would bet money, not even just bet money, I just know that if we go down here, this is the what would that be? The 23rd command in this list. So we've got 1, 2, 3, or sorry, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, oh, 23. Oh, wait. Wait, the hell? What the hell? Where, what? Okay, so we're skipping log. Oh, right, we skipped log. No, but wait, but it is 17, so it's 23. What the hell is going on here? Okay, so it's set scene is what we think it is, or whatever. Set something. Or scene set, that's what it was. Which is OC 12. So that's what we think this is. And scene set is right here. So maybe, wait, if I do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, that's also wrong. But not by much. What on earth? It does double it. Okay, wait, 1 second. Let's just watch what it does in the math. Okay, so we load up this. We load up 801BBAA88. That's this one right here. That is global script command FNs. And then what we're going to do here is we are going to get B8 we're storing that from our 4 here. We got B8. How do we get B8? Please tell me this. We need to look again at. Okay. B8. So hmm. Oh, wait, what? If the first command that we're seeing here is the log command, it would make sense for it to be 0 here. That would actually make perfect sense. Yeah, it is 0. Okay, so I was correct. I did count correctly this time. So let's go back then. We hit play again. And this time we load in to we load in D. Okay. So now D sounds more correct, right? Like we all agree that sounds more correct to what we were looking at previously. Because now we do 0 1 2 3 4 5 6 7 8 9 10 11 12 13, which is D. So D is 13. There you go. So we had confirmed that. So basically, if we wanted to make a log command, we would have to insert it right here, is what we just discovered. The 23rd command here is where log would go, but it's currently a 0. Okay. Okay. We are cooking. So the question is, how does it get that value? That's the real question here, is where does that value come from? How do we, how is that determined, basically? And I don't know is the answer to that question. There's got to be a map somewhere that determines. Maybe it's in a DAT file somewhere. I mean, I guess I could search for how many 17s can there be? Like, if I search for some of these values, there's got to be I have a function specifically for searching these archives. By the way, I can do a hex search over all of this stuff. So let's make a new command here, and we're gonna do hex search. That's what we'll call it. And then this is gonna be hex search. Hex search M, and let's also do the same. Actually, no, we have it right here. We have the working directory that we want. So hex search M ./mcb0.bln s, and we want to look for we'll look for 000. We'll look for 0017 first. I feel like that's going to show up a lot, obviously, but maybe it will give us something to go on. I don't know. We can ignore a lot of these, like the graphics files and such. Yeah, this is too many. Yeah. Okay. Let's try again. Let's not search that way. Instead, let's search for 000D, and let's see if we can search specifically for this here. Act like this is a real thing. 0000 002. Oh, 2. I doubt that this is gonna work, but it's worth trying. You know what I mean? Oh, well, we found some stuff. I mean, I guess that kind of makes sense. It's not a hugely original sequence or anything, but still, hey, that's kind of neat. So the ones that we are caring about is this FFFF. That's what we care about most. So let's look at file 78 and 84 in FFFF. So we have to unpack MCB is the first thing we have to do. So let's do that real quick. Oh. Can I still scroll up here? Okay, perfect, good. Actually, let's stop this because I want to not potentially lose that console if it keeps going. FFFF, just so you know, is like the data archive, the main data archive. And I'm getting messages on Signal. Let me exit out of that real quick for you guys so that we don't hear those little pops. Okay. So, can you track which files are read by the emulator before the breakpoint? See, the problem is not really. I mean, like, yes, kind of. The problem is that they get most of the files like this are like static files that get read in at the very beginning of the game. So it's not like they read in files. I mean, they do read in files as they're loading things, obviously, but like something like the script commands or whatever is going to be loaded in at the very beginning of the game. And so it's not necessarily as helpful as we would like. But okay, so let's try going back here. We're going to now do an extract MCB archive command. So extract MCB archive m mcb0.bln I -1, or do I type ffff? I don't know. Let's see what it says. int.parse I. So I definitely do -1. And then O, we'll call it mcb/fff. Let's see if that works. I'm sure there's something here that won't work. Yeah. Wait, -1 was not a correct format for a number? What? What do you mean? Oh, there's a comma? I put a comma after it? Okay, well, that, you know, we all make mistakes. Okay. Okay. That works this time. Oh, no, it didn't. I take it back. Out of range. Oh, it did not like that I gave it the MCB of -1? Did it hate that? I assume so. It must have hated. Yeah, because it's. Oh, it's. Yeah, okay. I think maybe it's 0 is the actual archive index. I don't know. I probably should rewrite some of this to make it like a little bit easier to use, but also I'm lazy is the problem. Okay. Yeah, there we go. All right. So we wanted files. So these are all decimal. Yeah. Awesome. And let's run this hex search again because I already forget which ones we cared about. That's why we have two separate profiles, by the way, so that we can do this. So file 78, 078, imhex. No, delete it. Okay. So this file has 9 sections here. First thing we're going to do is we're going to see if there's any text in the file, because that might give us a clue that like we're in the wrong place. So let's look and see if this is like one with Shift.js in it. And it doesn't really look like it so far. It looks like it's pure. Oh, nope, nope, nope. This is a topics file. So this file defines topics and stuff. I mean, like, you know, topics and flags probably. Yeah, club flags, timeline flags. Yeah. Okay. So this is not the right file, I don't think. Let's still look for what we were looking for before. We were looking for 000D00000002. So 000D00000002. So there it is. Actually, that could be something. Let's not close this. Did they have a 17 in here somewhere at the top? We might have cooked here. Like, to be honest with you, we might have cooked here. This might actually be hmm. If this is actually that's really funny if this is actually like how it works. That's really really funny. We might have cooked, honestly. So yeah, 15, 17, 13, 11, F, D, B. Yeah, we might have cooked. Okay. Okay, we'll come back to that. We'll come back to that. Get the chef hat out. Yeah, hell yeah, man. You know me. Okay. And then the other one was 84. Let's just make sure like I don't know. We're giving it some shots here. Okay, here's 84. I'm going to crash. Yeah, okay. So Imhex seems to crash when that's a bug that I need to report. It's probably the flat pack that's crashing specifically, not Imhex generally. Okay. But I don't really care. It's fine. Okay, so in here we got 10 sections. 000D 00000002. Okay. This one does not look like it's cooking as much because these are repeating. Like 0E, 0E, 0F, 10. That does not look like it's cooking as much as the other one. So let's bring the other one back out. And probably crash Imhex in the process. Oh no, it was fine this time. Okay. So 000D 0000 0002. Okay. So this first section starts at OX54 and it goes until does it really go to OX9870? That's like kind of insane if that's the case. There's only 2 items and it goes to 9870. That can't be right. Can you hear the fire engine? If that's the case, we didn't cook as much as I was hoping. Because then these are all related to the same topic stuff. Dang. Dang, dang, dang. Yeah, 1, 3, 5, 7. Okay, yeah, so there's not like any 2s here and stuff. So that okay, I might have jumped the gun. I mean, listen, let me go. Is there a 2 in here? There is a 2 right here. Okay. So this is 24 bytes, which is 18. And if I count all the way from here, that's 30 bytes. This is 24 bytes would be from here, right? This starts at 5-4. Huh. Okay, wait. So 5-4 is right here. And we have to at least include this 1. That's 28 bytes. And then this is 24 bytes. So this is OX1E 30 bytes. OX1E 30 bytes. I don't know. I don't know. This is kind of weak to go on here. I'm not sure. I mean, let's just see, like, what does this 3160 point to, right? Like, it's going to point to something in this file, probably. Oh, what? Oops, OX3160. It points to something that's in Japanese. Let's check. All right, I have to go back up to the top of the file. Yeah, so it points to this little phrase here. Imoto wa restaurant ni iru you da. Iru you da. So, yeah, okay. And that's TP sister wear, topic sister wear is what it's related to. So yeah, that's just like a topic definition. Ugh. Okay, I thought I was cooking, but I wasn't cooking shit, man. Dang. That's okay. We do our best. Okay. Oops, I did not mean to launch heroic games all of a sudden. Okay, anyway. Um okay. So let's keep thinking here. We'll keep thinking. Um like maybe yeah, we get the chef hat back in the cupboard. So true. We're putting that chef hat away. Okay. I'm feeling like maybe okay, maybe I can do something. Oh yeah, and there also I didn't even look for that FF. 08FF000D, maybe. Maybe I can search for that. That looks like that sounds a little bit more unique. O8FF. Oh wait. 0008. FFFF. OOOD. Let's just try. I mean, like, who knows, right? Maybe we find something, maybe we don't. But worth a shot. Yeah, it doesn't look like we're gonna find anything. Because if we were to find something, it would be up in FFFF. All of these are like specific to scenes and stuff, so they're not really interesting anymore. Okay. So I mean, like, I guess we can set like a memory breakpoint here, right? Like we can, but no, we already know what's setting it. Do we? Do we know what's setting it? No, we don't. Store script short. We actually did know that. We did know it was store script short. But where does the store script short get it from? Because that's kind of important. Because this is where it's storing it. It stores it right here, x26, and it stores this variable here that it keeps getting out from previous store scripts. So we have this plus hex 24, which is 48484C. So let's breakpoint that. Let's breakpoint that. Screw it. Clear our breakpoints, stop emulation, start a breakpoint, or make a breakpoint and then start emulation. Wait, it didn't hit. It didn't hit the breakpoint. What the hell? Okay, try again. Did I do it right? I mean, it should hit it. It's not gonna hit it? That's weird. It doesn't hit it. That's very weird. I guess we'll see. Maybe I should do up here in the if statement just in case it's skipping that for some reason. That's weird though. It's skipping that. I don't really understand what's going on. Okay. What? Didn't even hit that breakpoint. Am I doing something wrong with my breakpoints? No, these are address breakpoints. It should be right. Okay. This is conditionalized based on... Okay, let's... Okay. Wait, so like there's multiple store script stuff in here, right? So let's see if I can find. Oh, there's like a lot of places where this happens. Oh, this is the first place it happens, actually. I just said it in the wrong spot. Okay. So let's actually go back up here and set the breakpoint. Okay. All right. So we set a breakpoint right here, and then we launch. I just set it in the wrong spot. I'm reaching the breaking point. Yeah, I suppose so. But no, I have plenty of perseverance. Okay. So what is this doing here? So this is setting us up to store. So we have param1 is what was passed into this command. And param1 is CMD, or no, it's not CMD-def. It's something else. And CMD-def is this. So we're getting something from CMD-def, and we're storing it also in CMD-def here, it looks like. So CMD-def plus hex 12. This is an undefined 2, which I think it's just a short, man. At a certain point, you gotta just call things a short. I guess I can't. Can I? No. Okay. Actually, I don't know how to do that. Okay. Whatever. Oh, it's in store script short. I see. That I need to. These are shorts. Okay. There we go. There we go. Okay. So, basically what we're looking at here is the result of this, right, is it just iterates forward by 1. It iterates the source forward by 1. So this is effectively CMD def iterator. Done. Yeah, that's correct. That's correct. And so oh, it's storing it from 12, 13, and 14, and it's storing them in 24, 25, 26. Crashing out to desktop, Breaking Bad. Hell yeah. Okay. Let's do this. Okay. So our R3 here is 917C2F28. That's right here. And then what we want to do here is our R4 is going to be, yeah, so R4 is where this is coming from. Our 91407CF5 is where this is coming from. And that is 5 here. You can see it's 5 and then -1 and then 15 and then 1, theoretically, if we're going in order, if we are going correctly in order. Yeah. Okay. So let's see if that's what happens. So we should have here, this should end up being 5 when I step over this. Yes, okay, cool. So then the next step here is we move R3 into R4, the iterated R3 into R4, and then we add to R31 we add 74, so we end up at 2A, which gets us to the next step here. So 2A, and that should take us -1. Yep. And then the next one should be 15. Yes, perfect. Okay. And to be clear, 15, wasn't that the log command or something? I feel like it was. Yeah, log is 15. So something happens to transform it in this method, I think. Because that is the log command. This is actually a command struct. I recognize this now. This is the command, and this is this is like an invocation struct. So like if we look at our invocations in here, we have line number, which is the address, and then the character entity, then the command code, and then the number of parameters. So this is an invocation. So this is the line number, I guess. Yeah, that's the line number, not the address. Line number. So we have the line number. This is line 5. There is no character entity. It's a -1 character entity, and it's command 15. So that's an invocation. So we can actually mark this as an invocation, which is really helpful. So let's go in here, and we're going to make a new struct. And we're going to call it script command invocation. You know what? That's too long. We're going to call it that. Okay. And we're going to base it on this that we have here. So this is a short, which is line number. So short line number. And then that's also a short character entity, right? Yeah, these are all shorts. Short character entity. And then this is a short command code. And then the last one we have here is our parameters.count, which is a short as well. So short num params. And then I'm going to try to do something crazy that I don't think is going to work. Oh, it doesn't matter. This is just the invocation. We don't actually include the parameters in here. So the last thing we have here is an int, which is padding. Okay. So this is a script command invocation here. So this cmd def plus 12 is actually, we should be able to represent this whole thing. I think I can just like highlight the whole thing maybe and say this overall is I think I can say this is a script and inv. Did that work? I actually can't tell if that worked or not. I don't think that worked. I guess it did, kinda. Yeah, so line number to there. So yeah, we can also do, this is also, no, this is different. This is not a thing, but it doesn't matter. It's fine. So yeah, it starts by storing the line number, and then it stores the character thing, and then it stores the command thing. So this right here is the command thing. And then, yeah, this here. So then the other, we should also make another struct that is, actually, I don't really care right now. We're not going to do that right now. Okay. No. So what we're going to do here is, we know now that, I feel like this just made it worse to read. I'm going to undo that. Okay. Yeah, so this here, plus 2, 6 is the command code. And something happens to the command code. So we want to follow that through and see what's happening. So yeah, here's where it assigns something to it. So it does some fucking cursed math to it, man. If it's equal to something, then it gets this uvar. And otherwise uvar is equal to -1. And then it assigns that to that uvar. So this right here is our CMD section offset is what this is. That's what we're getting here. And where does it get it from? It multiplies it by 4 plus 2. And this ivar comes from somewhere here. Determine script param length. Yeah, this is crazy. I don't know what's going on here. Okay, let's see if we can determine what's happening. Let's go back in and see if we can figure out what's going on. Okay. So we're going to clear breakpoints, add this new breakpoint here. Okay. So our first one that we have here, I think we're here with 05 FFOF, right? Yeah. So we've loaded 7.7 as our ivar 7, which ivar 7 is what? Oh, there's like a loopy thingy that happens with the number of parameters. Oh, this is like storing the number. This is storing the parameters somehow as well. This is also CMD def plus 4, which is a whole other thing. And an integer of it. Oh, man. So I don't really know what ivar 7 is right now, but that's okay. We'll figure it out in a second. Yeah, it's true. Geeter does struggle with for loops. But so does IDA, really. So, whatever. CMD def, global CMD def plus 6, ivar 6. Okay. And ivar 6 is 0 here. Oh, this is because of the loop. I see. This is the loop. And this is also a loop variable because we just set it to 0. And then we set this ivar 7 to some constant thing. Not necessarily constant, but some value that's separate. This is our iterator. I bet you it's the number of parameters or something. I don't know, though. I don't know if that's the case. But okay. Let's do this. Okay. So 77. Oh, I bet that's the total number of commands. I bet this is the total number of commands, right? Hex 77 is 119, which was the total number of commands, wasn't it? I think the last one's like 7.6 or something. Yeah, 7.6. So yeah, 7.7 is the total number of commands. So this is looping through all of the commands in order to parse these out. Okay. We figured that out. That's good. So let's actually mark that. This is here. So let's split these out. These are all new variables, but we'll split this one out first. Num commands. Okay, cool. So that's num commands. Awesome. So while num commands is greater than 0, basically we're gonna loop through this, and we're gonna decrement down each time. And we're going to start assigning the command section offsets to this. It goes to this label, assigns the section offset. I presume it then pops back in somehow. Maybe not. I don't actually know how that works. That's interesting. So I guess this is just a break. Oh, maybe because it calls this for every single command individually. So like this is just it looping through all of the commands in order to find the right one, I guess. That kind of makes sense. I can see that. Okay. So let's see what it's comparing. We have this global CMD def plus 6. We don't really know what that is at all. That's some random integer. So let's find out what that is, and we'll work with it. So we have so here we have CMD def plus 4. We got that in there, and then now we've just done we've just passed the BLE here. So now we're here. We're checking CMD def. We're loading something. Oh, we're loading something to. Oh, that's not actually CMD def. That's just like it's the register. So we're loading. We're loading. We actually this actually is based on CMD def, right? Because we're loading this plus 6 into whatever this register is. Oh, I guess I can just see RAR4. So R8 is CMD def, and R8 is right here. This one right here, and we're loading the 6th short in as an integer, I guess. We're loading it 12 steps in as an integer. Okay, so that is an address that just got loaded in. So if we can go there and see what it is, 90403D30. Okay. Interesting. Is this a map between... Is this just an exact map between the different... I think it is. I think that's what this is. I think we just found exactly what we were looking for. This is a file that gets loaded in somewhere. Let's search for it. Okay. So we want to search for 0000000001. Oh wait, no, sorry. Oh yes, 0001. That's right. And then the next one is 0001 0005. 0001 0005. That actually should probably be enough. And also I'm going to demonstrate what I'm talking about here for a second. Hey, Will, get the chef hat back on if you're still here. Get it back out. So here's what I'm thinking. Basically, back is 00, right? But in Ghidra, if we go to where this is, back is the 1th index, right? And so that's what this 0001 is. And then this next one, 0001, is 0005. So what that means is our 5th one, which is cback, 0, 1, 2, 3, 4, 5, is the command right here. So yeah, that is the file. We found what we're looking for. Is there something in the dat.bin one? No, but we see a couple elsewhere. So these are actually, this is maybe promising. I don't know that it's promising. 9,000 probably not, but 4E04 could be. I also maybe should search dat.bin because it's possible. Do I have a bin archive search in this? No, but I can just bgrep over it. Do I have bgrep installed? I don't. Bgrep. Do I take the Rust one or the non-Rust one? The Rust one seems a little bit more robust, doesn't it? Yeah, we'll just use the Rust one. Okay. So how do I install this? Is this... Is this... Okay, I assume this is for Linux. It's got to be for Linux, right? Like, no one just makes something like this. It's... Okay, yeah, whatever. Okay. So let's go stick this somewhere. Apps. Egrep, I guess. Okay. If I run bgrep, okay, chmod bgrep. Oh, awesome. Okay, so it doesn't have any dependencies. Cool. So what that means is I can, I'm going to move it, bgrep. Okay, cool. So now what we're going to do is I'm going to close out of apps here, and I'm going to load up my dat. This is MCB, so we're not doing that. We already searched the MCB. We're going to load up dat here. We're going to search. So we're going to do apps bgrep. I spelled bgrep wrong. Nice. Okay. And we're gonna do a folder search. So show me how to do that, bgrep documentation. So our pattern. Yeah, okay, so definitely we want B then. And our pattern is this. But with /x in front of each of them. Probably could have done this with like a regex thing, but it's not that many letters, so I don't really care. Okay. And then I guess we can just do that. Oh. Is there like a recurse thing? Star? Okay, yeah. So it is working and they just didn't find anything. Okay. Okay. Okay, we can try something else here. Let's extract some more bins and keep trying. It wouldn't be in GRP, but it could be in SCR. That would make sense for it to be in SCR, maybe. Or it could be hard coded in the ROM somewhere, honestly. It was in the 9000, so it wouldn't have been. It would be loaded in. So let's do extract bin archive. Did I already extract SCR? Yes, I did. Yes, I did do that. Awesome. Oh, hell yeah. You got 2 matches. Who knows if that's good or not? I don't. But might as well take a look. So it's 219 and 221. That's what matched. No crash logs for you developers. You're just going to be like, it's a flat pack. This is an actual script. Oh, is it though? Is it an actual script? Yes, I think it is. Yeah, it has dialogue in it. This does not look like the file. Okay, we'll try 221. Is that going to crash? Yes. I think the imhex flat pack is just kind of unstable, honestly, but I also don't really care. I could install it through Ubuntu or something, but I don't really care. Okay, this is also not it. Hmm. I'm confused. So it has to be in EVT bin, grp.bin, dat.bin, or scr.bin. And it realistically would be in dat or scr. It wouldn't be in the other two. Or it could be in the ROM somewhere and just getting copied into memory. Like, it's very, very strange. Or it could be constructed, I guess. Here, let's just set a breakpoint on it. Like, let's set a memory breakpoint on this and see if we can figure out where it's being written. 91403D30. And we do a range to 9143D5. F, I guess. 9143. Oh, wait, that's not right. 9143. Is this right? 1, 2, 3, 4, 5. No. 9140. Okay. And this one's right. 1, 2, 3, 4, 5, 6. Okay. Yeah, cool. Okay. We'll copy that one at least. And then now when I stop it, it will delete that breakpoint. Maybe it will keep it. Okay. So 6B is the wrong value to have written there. So this is something else. I think, yeah, this is decompressing some file. And we're going to have to wait for it to decompress all of that file in this region that I marked off, this large region. So that's unfortunate. Let's see if I can modify it so that it doesn't have reads at least. Oh, it is just writes. Interesting. Okay. Oh. Okay. Now this is correct, I think. Yeah, store script short. So it's storing the script shorts here. Load script. Wait, what? So it does half of it. Hello, Gig. How's it going? So it does half of it in. Huh. Or does it do all of it in one script? Okay, so like I should see where this one's getting called from somewhere. This is store script short. It's getting called from somewhere. Step out. It's also from load script. Okay. So let's go to load script. Okay. And we're on this line here, 8020980. Okay. So it does construct this dynamically based on some shit. Wow. That's kind of wild. I'm glad to hear you're good, Gig. That brings me joy. Okay. So this is constructing the table. So huh. Okay, so command index is that command index. So that's just found through this, through that checking the hard-coded commands apparently. Wait, what? Oh, it's just they're all right here. This is the order that they're in. Okay. Yeah, they're just in the ARM9. So this is the order that they're in, and it just maps between the two of these. Mein Gott. Okay. Well, I guess that's fine. I guess that's fine. Okay. Well, yeah, I guess we did it. Nice job, gamers. Okay. Yeah. Okay, so this raises some interesting questions, though. Um, so this tells us like what order they were supposed to be in too, which is kind of cool. And we're gonna copy this out, obviously. Nice indeed. All right, here we are. That should be everything. Okay, excellent. Okay, and so one thing I want to do is like a line count on this. Yeah, whatever. Tools for noobs. Yeah, that's me. Okay, yeah, so 128. And if I remember correctly, oh wait, that is in shit in decimal. Yeah, so there's 9 more commands in here than there are actually defined in the commands thing. Yeah. I'm glad I could help you with that. That's awesome that you still remember that. I also remember that working on that one. Thank you. Yeah, this is crazy actually. So there's some commands in here that aren't listed in the other commands thing. That's kind of wild. So let's just make a list here of these. And we should be able to like compare SQL. You think this is a SQL file? Whatever. Okay. I guess that kind of makes sense. I can kind of see that. So yeah, okay. Interesting, to say the least. Um, huh. So I guess okay, so this is really cool actually. Because now we have this list. I'm gonna make this plain text, please. So now that we have this list, we have the exact order that the commands were supposed to be in, right? Um, which means we can actually go into some of these commands here. Like, for example, this function is supposed to be a command, right? It has all of the stuff that the commands do, but it's right before abtse. So is this sound stop? Do I have sound stop documented somewhere? I don't. So this was sound stop. This command right here was sound stop at one point. And it got so deleted that it got less deleted some of the other ones, I guess, but cmd sound stop. Or sorry, command is the one we use here. Command sound stop. Okay. That's very cool. So let's keep going. Yeah, so S sound effect stop is SE stop there. Command SE. So let's keep going here and let's just see if we can find some nice Okay, so this one is also probably something. So omake data would have been but okay, so no. So this is omake EBT still right here. So that's fine. That's normal. Okay. And then this is omake middle, omake sound, and then S menu lock. Although there is this TWNH that is in there. Huh. I don't know about that. Okay, I'll look into that later. Tutorial. Yeah. Okay. Yeah, I don't know what that is. That like in multiple? No, just right there. Okay, interesting. Tutorial random. Here is random. Here's set time. Yep. UI. Yep. Name change. Yep. And then we have dialogue. Yep. And then obviously the selects are there. Okay, this one's a little different, but I think it's referenced by it's referenced the CMT commands. And this is CMT topic use, sure. Topic using, sure. Topic vanish, sure. Topic change, topic get. Just topic. Tdel. We skip topic. Huh. That must be zeroed out in the mapping. Okay. Here is TNW NH. So yeah, this is just so it's not perfectly in order, but whatever. It's pretty close. This is TNW. The next one will be TW. Yep. MW. Yep. Sub add set. Add set task. Sure. vcall. Oh, we didn't have a name for vcall, possibly. We had call and we have vjump, but we didn't have vcall yet. So this is vcall. And it fully is functional. Like that's the other thing that's interesting about these is a lot of them like they've taken out the code, but these ones are fully functional. So we could totally like use these these completely deleted commands with like a quick little hack. Vjump, jump, text. This is text. I thought text was in the game. That's text. So what's this then? I don't know. I'll have to look into that. Here's another one that could be something. Oh wait, no, these have xrefs. So this is referenced. Between wait and text. And the thing between wait and text is locate. So I guess this is command locate. Can't use it because it's not in the script commands, but it's there. Probably should leave a note here. And wait. UI date place. UI place. Whatever set DV does. What's Flynn? Is that friendship level? Or something else? I don't know. Alright, documented Flynn. As best I can tell, has no effect. Okay, well, I mean, like, yeah, it kind of does look like it has no effect, doesn't it? Yeah, it really looks like that. More than 3 hours, grab a snack. Yeah, I'm gonna take a nap soon. That's what I'm gonna do. Blur. Blur is in there. Wipe and wipe. OL end. OL FT effect end. FT effect ST FIFO. And then fade. And then is this is set P flag now. So it skips log print con error and disp RST n and go straight to set P flag. And then up to loop minic and so on and so forth. Loop CTU. Okay, so I'm curious. if we go down here where this is, yeah, so set p flag. So yeah, these ones are all blank between fade and disvar_stn. This is what these commands were. They were error, con, print, and log. But probably implementations of them don't still exist. Okay, what's this one do? This is a full command in like between commands. It's between command text, command jump. Is there something between text and jump in here? No. This definitely does something. Um, but what does it do is the question. Mm-hmm. So let's see. So we calculate these, get params and all that. Okay, so this is an XY thing. I don't remember if I typed in this XY or if that's just something that Geeter determined that it was based on, oh, it's because it's using load dialog line. So it's X and Y based on that. Holy shit, is this print? Is this print, guys? I guess we can find out, right? So the way we find this out, let me first, I have to clone some stuff. So I have to clone the assets repo and the strings repo. So you guys are going to get a little preview of some things to come, but I think that's fine. And then we're going to do open Heiretsu translation assets. And I'm actually going to delete most of the assets here. Like all of the graphics are going to go. I'm going to check out a branch. Oh, wait, I have to go into assets to do that. Okay. So and we're going to delete the models as well. So we're not dealing with that right now. Movies, fine. Events, fine. Data, fine. So we need a scripts folder, I think, to do script replacement. If I remember correctly. That's how that works. So there's replace files command. And the events is an actual, oh, so it doesn't have the directories in here. Okay. Okay. Dat, EVT, GRP, SCR, archive index. Ah, I see, I see. That's right. Okay, I remember how to do this. So, um, the first file here is this one. Um, so let's replace it with okay, I'm gonna hide this for a second. Oh wait, no, I have another one up over here. I'm just gonna go to Weblate real quick, and I'm going to wait. No, I have the Weblate up already. I'm going to look up what the file name is. Okay. So this one is this. And I think SWS is hard coded. Yes, it is. Okay. Okay. So now we can open this up. And we can just paste this in here. Also, let's search and see if there's any prints in here. There are prints in the tests, in the test scripts. Interesting. It's kind of cool. It looks like it was capable of like printing variables too. I think it prints to the screen. So let's print at the top. We'll do it after the event loads and plays. So this is the in section, just so you know. And then there's the out section down here when it unloads. So let's do the Haruhi section. Like we'll do right after her first line of dialogue, I think, right here. Oops. Print. Yo, Kyon. Wait, no, it's not dialogue. This is a test. Is this on screen? Okay, let's do it. So that's step one, is we have to actually patch that in that way. Step two is to we can pull up translation build here, which this is a public repo, so I'm not revealing anything here, but this is the restore commands thing. So I actually wrote a print command that like logs to the logger. I actually wrote one that does that, which is crazy thing to do. But yeah, so to be clear, so this is the subroutine that we think is print, just based on it alone being looking like print. Well, it has an X and Y, doesn't it? It takes an X and Y coordinate. And it's pulling out of the... Oh, but you can have it default to... Huh. Something, I don't know. Oh, if those params don't exist, maybe? Yeah, it just does something. Okay. I mean, let's see. So the other one was there was con, and there was error, and there was log. Yeah, log is not. Log just enables logging. It doesn't actually print. Hmm. I bet. Huh. Okay, let's see. Hmm. I'm kind of like, I bet that, like, yeah, I don't know. Here, 1 second, 1 second. Okay, let's go to this address real quick. I just want to check something. Um, so that's there. And then there's the global command defs. No, that's different. Commands hard coded global commands offset. This needs to be based on my naming conventions. Global commands offset and global offset. Okay, so it goes error con print log. So back here, error con print log, right? So this is print. This is log. Okay, so I need to probably comment out my print, my version of print, and replace it with this. So ref is the thing I can do. I'm going to do the same ref thing. And then just do um okay. I forget how to write PowerPC a little bit, but that's okay. Um, I'm pretty sure I can just do like dot int. Okay, let's actually we have Dolphin as a PowerPC assembler. Dot int dot word 5 OX05. Okay. D word dot byte. Okay, dot byte works. So the concept here is good. It's just I'm using the wrong words. So I need dot half word dot double dot. I just should look it up. PowerPC. Are these assembler directives? Assembler directives. Okay, okay. So dot long is what I'm looking for. Okay. Oh, that didn't work in there. Okay. Dot byte. Does dot short work? No. Dot long. I have no idea. I think it will work if I... It's the same as dot word according to this. So I think if I just do dot word and then I paste the one that I think is print in there, I think that will work. Was it? It was this one. It was like one that was in between things, right? Not this one. This one's fake. These are real ones that we think are actual things, probably. No, this one was one. This one right here. This is a real one. Okay. I think this will work. Actually, this should be a REPL. Okay. How do you do a REPL? Yes, it is. Okay. Okay. So I think that will work. Yeah, I think this will work. Okay. And then I guess is there a Docker? I don't have a Docker thing yet. Okay. Oh shit, I have to install PowerShell. It's great. No, you know what? No. We're doing Docker. We're doing Docker. There is a Docker container for this. Docker run. And I'm almost gonna have to be done for the day, but we're gonna try to finish this up real fast. CI containers. Heiretsu dev kit PPC. Docker run. ITV var home Junko code Heiretsu translation build work w work dash. Okay, this should work. WSH. All right. And then I think I have to extract this ROM to, this is such a complicated process, but it's fine, to Heiretsu translation build as R4 J, wait, R4, okay, it's in here somewhere. R44JP, R44JP.iso. Okay. Awesome. Okay. Um, and I guess I have to put that in. Oh, shit. In original slash that. Uh, for real? How do you wait? How do you run PowerShell scripts now? What's the what's the magic? What's the secret sauce? Oh, I see. I see what's wrong. We have to do uh, on this side. Yeah, there we go. Perfect. Okay. All right. So we first do our setup. Then we do build arc. Which I can. Shit. I didn't. Oh man, I didn't know. Okay. I have to do it this way. To reference code because I have to get to the other repos. Um, Heiretsu CLI. Okay, there we go. Assets folder, strings folder. Font size. I forget what our font size is supposed to be. Let's check the Azure pipelines. Font size, we do 20 usually. Okay. 20. And then lang code is en already, and we won't do copy too. Okay. Oh. Okay. That's fine. Sudo apt. Really? glibc is out of date? Apt upgrade, update, apt upgrade. Has the Heiretsu build been failing lately? I thought it was working still. Don't mind me. I don't even know that this will work. But like, if the Heiretsu, we build the Heiretsu build on Docker on Linux, doing these exact steps. So like, I'm kind of confused if it's working. When was the last time we had a Heiretsu test build? Yesterday. So yeah, it should be working. Okay. What on earth? Okay. glibc. Let's see. Oh god, that's gonna be so many things. I just realized. Oh, maybe I just need to install .NET. No, but I have .NET on this. Yeah. Why is this not working? Maybe I have to build it on this machine. That might be it. Yeah, I think I just have to build it on this machine. So, okay, so let's do that real quick. I'm so sorry. Heiretsu translation utility. Sorry, 1 second while I page to OBS so that I can see. Okay, cool. Okay. So let's do this. .NET clean. Okay, we're trying again on here. .NET clean. Oh, right, it doesn't have .NET. Okay, it's owned by Ubuntu. Oh, but it's not owned by the thing. Okay, let's try doing a clean here. I think I can do that somehow. Oh, probably terminal. .NET clean. Oh my god. Oh, it doesn't matter. It's because of that. Oh, I see. Never mind. .NET clean fnet 8.0 should be. Oh, okay. Okay, whatever. .NET restore fnet 8.0. Restore project. Already, it's CLI. Actually, just do build. Haruhi Heiretsu CLI. Heiretsu CLI CS proj F. And we have to do project. And we do framework net 8.0. Really? Is that I just have to do F and P? Oh, for sure. Let's deprecated those. Okay. Sure. That doesn't seem right. That seems very wrong. Maybe I just need to do no P. There we go. That seems more right. Okay, cool. And then now we can go back to here it's translation build and do this. There we go. Now it works. Yeah, so I did just have to build it on this machine. Okay, cool. That's fine. On the Docker container, that is. The next step is to do build.ps1. So we'll just wait until this is finished. The string replace takes a while. I should really fix that probably. I mean, there's probably some bugs in it, which is probably part of the problem, but we'll see if we can fix it still. Graphics replacement takes a really long time though, so that's why I deleted all the graphics at least. Here's where the patch gets created. This is actually a Revolution patch is what they're making right now. What are the oh, the font, yeah. So yeah, I should probably pull up Dolphin's Revolution thingy as well. Nemu and load. Revolution. Actually, no, I think it just goes in here. Like Heiretsu in the load folder, they'll generate a Revolution folder as well that we merge with the two of them. All right. It's getting there. It's taking freaking forever, but it's getting there. And maybe I should have deleted all the strings too to make this go faster. I will do that if I have to do this again. Delete the strings. I probably should do that anyway. Just so I don't spoil it. But now I'm like sunk cost fallacy and I don't want to change. Okay, here we go. Failed to compile some lines. Well, that could be a problem. That would probably be where the bugs are. All of the bugs is in failing to compile those lines. gonna screenshot this and put it in the Discord. Slow. I don't know. I think this will work though. So yeah, we're definitely gonna delete the strings, because there's a lot of them. So definitely we're gonna delete the strings in a bit. Okay, there we go. It's saving. Saving DAT, saving EBT, saving SCR will take the longest, but it'll get all of them. Yep, there we go. And so then the last step is build.ps1 Heiretsu CLI. Oh, I need we inject too. God damn it. We'll just clone on this real quick. Actually, no, I have to clone it. I don't have Git credentials on that, so let's get we inject real quick. I really need to improve we inject. It's not very good, to be honest. It's not my best work. So I really need to work on improving it, but I just haven't yet. All right. Here we go. Build.ps1 Heiretsu CLI Heiretsu translation utility slash Haruhi Heiretsu CLI slash bin debug neteo Haruhi CLI. Okay, and then we got we inject dot slash we inject slash we inject slash bin debug neteo we inject. Oh fuck, DevKit Pro too. Do I really need DevKit Pro? I do need DevKit Pro. Oh wait, no, I have DevKit Pro. We're good. We're good. I don't even have it specified. It's on the path. It's on the path. We're so good because we're in the Docker container. Yay. Okay, cool. And we're not going to patch the doll. Oh. Okay. Well. DevKit Pro opt slash DevKit Pro. There we go. Excellent. We did it. Now I'm going to delete all these strings. Check out a branch on that one too, actually. Okay. And then now we can go into Heiretsu translation build, patch, take these two folders and copy them over here to load Dolphin and right into Revolution, please. And so now we have this Revolution patch and we have these Heiretsu patches, which is awesome. So now we can launch the game. Start with Revolution patches, open Revolution XML, open this one, and we're going to enable the full game translation. We're going to enable restoring some commands is what we're going to enable. We're going to hit start. Yeah, I do want to stop the current condition. Okay, sorry, that didn't work. Let's try again. I don't know why it failed to create the Vulkan backend there. It, oh, okay. That's not good. No. Okay, let's try it. Let's restart Dolphin. I have no idea. If it doesn't work, then I'm just gonna have to log off for now, and I'll probably honestly, I'm probably planning on doing a couple more of these streams this week because I am gonna be working on Heiretsu the whole time. So might as well, right? Okay, cool. Yeah, the Vulkan swap chain's fine now. All right, so we know what we're expecting, right? We're expecting that when we talk to Haruhi, something will happen. And we have the log here to confirm if anything happens, hopefully. If it logs. I don't know if it will log. We'll see. Okay. We're going to skip so you guys don't see this. Okay, when we talk to Haruhi, something will happen. Hopefully. Okay. So that's the first sentence. Oh. I don't think anything happened. I didn't see anything at least. Okay. So what we should do now is, well, first thing I'm going to do is I'm going to recompile the archives without the text so that I don't have to show that off. So first thing we're going to do is I'm going to recompile the archives. And then after I'm done recompiling the archives, I'm going to set a breakpoint for that print function and see if we hit it at all. Or if it's just, or I'm gonna set it, I'm gonna look and see what's going on there basically. There we go. That was extremely fast compared to what we were doing with previously. So now let's do this. Right. Okay. So, let's get this started, and then while we're starting it up, let's look at what we did. So we replaced this right here. So let's check this in memory real quick, actually, and make sure that it looks right. Dual view. So this, we were expecting it to be 800. That is not quite what we were expecting, is it? Oh, is this a reference to it? So, like, if you go to this, 801B, I bet you I know what it is, yeah. So I bet you this goes to 8018 AB8, 8018 AB8, 8018 AB8. No. Okay. I'm not sure then. I was pretty sure that, did I just read that wrong? No? I'm not really sure what's going on then. That's weird. So, if we look back here, So it is replacing something here, right? Because like this shouldn't have anything here. Let's just try, maybe we can try typing it in ourselves and just see. Like, I don't know why the Revolution patch isn't doing it correctly, but let me try typing it in ourselves real quick. And then I'm going to log off for the night because I got to go to work. So this is 8004. This is very strange that it didn't do what I was expecting. And then F8CC. Okay. And let's set a breakpoint for that same spot. Just to see. Oh, hey, it still replaced the text even though whatever. Okay, it hit the print. So we should see something show. Hey, look at that! Oh my gosh. Okay. Well, mission accomplished for now. We'll figure out exactly why it's not working the way I want it to later. But that's a pretty big win for one night. So I'm very happy with that. Yeah, we did it. Okay. Like I said, I think that's it for the night, folks. Thanks so much for coming out and hanging out with me if you're here. And if you're not, thanks for watching the VOD. That's also really cool. But yeah, thanks so much, folks. Hope this was somewhat instructive as I sat here and just kind of like messed around for a little bit. Like I said, I'll probably do some more of these pretty soon. So anyway, thanks so much. See ya, folks. It's been